General, ladies and gentlemen, good morning. I'm Dave Vickers. I command 8th Brigade. I'm also a member of the Council of the Institution of Royal Engineers. So in both capacities, I wish you all a very good morning, and I thank you for taking time out of what I know are very busy diaries to come and join the conference today. Can I also just start by recognising the awesome job that Peter Egan has done in convening all of us here today. Thank you very much. So the theme of the institution's first conference on sustainability is operational infrastructure and the drive for self-sustainment. Over 2 days and 4 panels, the conference will explore what actions defence needs to undertake today and in the future to reduce its engineering impact overseas and to help us facilitate the UK's sustainability objectives. So for non-institution members, let me just first tell you a little bit about our institution. The Institution of Royal Engineers is a learned society that seeks to advance the art and science of military engineering by sharing experiences, best practice and emerging thinking. If you delve into our charter, which is, John will be here, I can't remember exactly how old it is, but it's 18 something or other, so it's pretty old. You'll see that our objects include the general advancement of military science, promoting the acquisition of scientific knowledge in relation to engineering as applied to military purposes, the promotion of efficiency in dealing with problems in relation to the defence of both our realm and our dominions beyond the seas, and materially assisting the higher interests of the state. So right now there can be few higher interests of the state than dealing with climate change and sustainability. And we are thankfully well past the point where we're actually arguing whether climate change is a defence of the realm issue. It's now well recognised that the threats and opportunities that it poses, its impacts, and the responses of both state and non-state actors all affect our defence and security interests. That's why last year's integrated review set tackling climate change and biodiversity as the UK's #1 international priority for 2021 and beyond. And it's why the subsequent Defence Command Paper set the ambition of the UK being a global leader in its response to geopolitical and conflict-related threats exacerbated by climate change. Now, our institution and the Royal Engineers more generally have a pretty rich history in helping navigate the novel changes that defence has had to face in the past. Manned flight, wireless, chemical weapons are all areas where the Corps has played a pretty prominent role. And now sustainability and climate change needs to be added to that list. Recent and current events could not give more irrefutable evidence of the need to do that. Climate change is clearly fueling instability, migration and extreme weather. We saw that ourselves this year with the hottest UK summer on record. Energy markets are now being weaponized by Russia to deter Western involvement in its war in Ukraine. And the subsequent energy crisis is directly affecting the lives of all of us in the UK and much of the world more generally. Focus of this conference then is sustainability in our overseas infrastructure. It looks to explore the issue from a policy, a military and an industrial perspective. And of course, this is a problem that we're not going to solve unless the military and industry work through it together. The aim of the conference is to identify short and long-term engineering strategies and their internal and external training requirements. Each of the 2 days has a set focus. Today, we'll concentrate on sustainable operations and their present and future engineering solutions. Tomorrow, we'll look at the training and research required to enable these sustainable operations. We'll start today by looking at the future operating context and the concept of self-sustaining bases. What does sustainable operations look like today, and how might they change in the future? What are the present and future operational infrastructure requirements, and what is the industry approach to delivering sustainable, deployable infrastructure? Today, we'll also explore the importance of design in sustainability. How can design allow us to better target carbon and energy hotspots in our operational infrastructure? How can better design reduce our engineering impact on water use, waste production and energy usage? How can better design limit our impact on local environments, therefore also set an example for others to follow? So our reconstruction missions can set regions on a sustainable path of future success. Tomorrow then looks at support to sustainable deployments through culture, education and training. We'll look at the lessons already identified for climate adaptation in our overseas basing, and then we'll look at future and present delivery programs. It will also consider how we can work with partners to deliver sustainable engineering, mentoring and training. And the final panel tomorrow will consider the role of disruptive technology in construction, operations and support. There are, of course, considerable benefits if we can get this right. If we get it right, then we can embrace the benefits of low carbon technology, which can enhance our capability and help us to win. If we get it right, we can optimize our resources, thereby saving money and minimizing waste. And if we get it right, we can ensure we're capable of dealing with and overcoming the challenges presented by climate change. And last but not least, if we get it right, we can ensure that we attract and retain the next generation for our workforce. Many of them do not want to work for an organisation which is not seen to be actively tackling the problems of climate change. And they really do get this. So I was recently briefed by one of my squadrons, 70 Gurkha Field Squadron, who are on a construction exercise in Cyprus. And the squadron commander and his young team very enthusiastically briefed me on their carbon usage and the various steps they've taken during the construction exercise in Cyprus to reduce it. I'd taken part in the exact same exercise in the same location over 20 years previously as troop commander with a work programme given to me by Adam Foley. And I can assure you that Adam and I had absolutely no idea what our carbon usage was during that exercise, let alone any knowledge about how to go about reducing it. So in many ways, the approach that 70 Squadron took on that exercise is one that we need to adapt on a more macro scale. We need to baseline our carbon usage, just as that squadron did on that exercise. And then we need to focus what, in many cases, are limited resources in the areas that can have the greatest impact. To get to that point, we need to move environmental and sustainability knowledge into the very centre of engineering delivery for the Field Army. We've done that before, so health and safety, project management, these are functions that we've elevated up such that they actually drive the way that we deliver engineering for the Field Army. We now need to make sure that we do the same with sustainability. There's an awful lot to do to get to that point, but I think this conference is one of the early steps that's necessary to make sure that we get there. I thank you all for attending today, and I look forward to your active engagement throughout the 2 days. Thank you.
So, thank you. Just to go back to my earlier statement, the sponsor's not here, so I'll just step in and take over that role. Yeah, well, thank you for them opening words. So, we're now going to move into our first session. As you can see, this is being sponsored by us, which means some of us can go to this evening's event and no cost. Anyway, so what I'd like to do is invite our first speaker up to look at setting the context for what we're talking about today. So, ma'am, I'd like you to invite you to the podium.
Just get rid of that terrible photo. Good morning, everybody, and thank you for the invitation to come and speak this morning. I'm Air Commodore Lt Baker. I work in defence support for a general that I think is well known to most of you, Lieutenant General Richard Wardlaw, who is of the Royal Engineer extraction. So we are a cross-cutting defence function. We are all about trying to join the dots across logistics and support as a horizontal strategic layer for defence. And so our role, if you haven't heard of us, we're an HLB that sits within UK Strategic Command, formed a couple of years ago now, from what was ACDS Log Ops, logistic operations, now an elevated 3-star organisation, because there was a recognition in defence that support was not getting the investment and the priority it required. Over a third of the defence budget is spent on support, and yet we focused, certainly in the head office, on operations or on acquisition, capability acquisition. There was very little championing of the end-to-end support in defence. And so that was why the Chief of Defence Logistics and Support, the first incumbent being General Wardlaw, was created. So for those of you not familiar, I think that's an important bit of context. And I'm one of his team, and my role is morphing all the time, but currently I think I do head of futures, so anything that's thinking about where we're going with logistics and support. In that very much now sustainability, and we're growing our own team that look after sustainability with Imran and Marina, 2 of my team members here in the audience. And I look at energy as well. The Defence Strategic Fuels Authority, that many of you may know, clearly still referred to as a fuels authority at the moment, but that is going to become an energy authority pending decisions coming up at the 4-star board next month. That will morph into being a defence energy authority. So we're all about the thin layer of strategy and policy that is trying to frame and support the more detailed activities and sustainable design that you're going to be talking about in more depth today. So I hopefully, whilst it may seem quite strategic, it is all about getting that top part of defence in the right place to support the wave of bottom-up activity and the kind of things you're talking about on exercises where there is so much energy and enthusiasm to try and make sustainability part of the solution to the future force, not an imposition upon it. And that's a phrase that my general uses all the time. This can be certainly part of the solution, and it doesn't have to be seen or perceived as an imposition. So that's me. So why sustainable support? Some of this is evident, but it's worth just reminding ourselves of that cascade. Obviously, UK policy and direction that is sending us in that sending us down the pathway towards net zero 50. Importantly there, I'm sure many of you will be aware of the MOD climate change and sustainability strategic approach authored by no other than General Nugee, sat in the front row here, which has set the first piece of high-level policy for the direction of travel for defence. Very much overdue, but when that was published in March last year, of course, a very welcome top-level piece of direction to start setting that framework. In our doctrine and concepts now as well, particularly the support operating concept, which was published earlier this year from my own area, very much framing how we deliver support in the future through a different lens, thinking about that greater agility, responsiveness, a smaller footprint with more precision, all of which leads us to more sustainable solutions and the future force solution. Thinking about global threats as well. Characterized, I think, really well by the US, the immediate pacing and shaping threats to the globe. The immediate threats fairly obviously being Russia, the pacing threat being China, and the shaping threat of our time being climate change. And so if you can use those terms and help argue that case, of course, we have to prioritize our activity on the immediate threats, but don't forget those shaping threats that are out there for delivery of our capability. Interoperability is part of that. I mentioned the US there and the way they characterize it. We need to stay in lockstep with our allies and partners. And if sustainability is the charge, we should be absolutely doing that in conjunction, especially if we think about a world where we've got a more diverse energy source. You know, we've been working for years on a NATO single fuels policy where we all try and use one sort of source of fossil fuel together. And even that's been pretty hard. Imagine how we're going to cope in a world where we have got the multiplicity of energy sources that we will probably discuss and think about in this conference. So we have to stay in lockstep with our partners and allies as we do this. Touched on by the Brigadier, changing societal trends. We need to be an attractive employer. We need to make sure that people want to join the UK Armed Forces. And us having that social responsibility and demonstrating our ESG credentials as a public sector organisation is vital for that recruitment. And I think perhaps that's been my view is that's underestimated by some of the senior leadership in defence today. So in terms of the vision, this is the Defence Support Strategy vision. I won't dwell on this, but this is just to say this is the first document in the cascade from General Wardlaw's area. The concept of support advantage, very much about sort of how we enable the war fighters, of course, to get to the fight and to win the fight, and defined as the ability of UK defence to deter and, if necessary, outcompete its near and peer enemies by our key capabilities being more availability, more of the time, where and when we need them, and possessing support chains which are more resilient than those that oppose us. And so we draw from the concept of support advantage very much into the concept of sustainable support advantage, because they come together. They can both be They are coherent concepts, not fighting against each other, is what we would argue. So we've taken the vision and the strategy out to 2025, and then focusing in on that development of environmental sustainability, we've gone on now to develop a sustainable support strategy. So what is that all about? So this is the initial response of the support community to the challenges of climate change, very much working closely with the Climate Change and Sustainability Directorate that was formed as a result of General Nugee's original strategic approach. We worked with a partner, Boston Consulting Group, and did a huge amount of stakeholder engagement across the frontline commands. We don't want this just to be logs and engineering personnel fascinating themselves. We need this to be capturing the minds and hearts of everybody across defence. So the idea is that we can try and provide that framework and that influence across defence. So a defence-wide perspective, but then honed in, what we're going to try and actually do is honed in on areas that CDLS can actually affect, because there's no point in having a great strategy and then no way to deliver it. So moving from, very much the theme of this, moving from that sustaining at reach to designing for self-sustainment forward, making our deployed footprint smaller and more self-sustaining with greater resilience built in from the very design phase of equipment onwards. And fewer people deployed, shorter supply chains, etc. All the things that I know we're going to delve into in some depth. The strategy itself is based on the same epochs as well that came from the original strategic approach. Activity now out to 2025, but very much looking to the head marks at the end of Epoch 2 at 2035, and then eventually to 2050, and the net zero ambition of the United Kingdom. So there's 4 dimensions that come together. I love these consultant strategy pictures with clip art, but I think this does bring it together quite nicely. The fact that every time we look at what we're going to try and do, we should look at it through these 4 dimensions. This is the framework to try and help us make sure that what we're doing in one area is not going to impinge and then diminish our sort of military capability or our effectiveness. So our aim is to extend the support advantage by reducing our vulnerability to environmental risk. This is very much about preparing ourselves to operate in a climate change world, as well as deliberately mitigating the environmental impact of the support activity across defence. And at the same time, seizing the opportunities to improve our capability where we can and our effectiveness and efficiency. Now, this isn't fairyland. We do know that some of this is going to require, of course, a lot of upfront investment. But the key will be, of course, selecting the technologies and areas where you can justify that investment and then reap the benefits from both a financial and a operational perspective over the longer term. So the strategy itself that should be published on .gov.uk on around the 6th or 7th of October. We're just waiting for a final endorsement at the Defence Support Board on the 5th of October. So all being well, this will be widely available and published very soon. Frames around 6 areas. Again, areas that CDLS can actually make a difference to in order to achieve the aims that I've set out. So the one I'm going to focus on here is number 4, because that's where this conference is definitely focused, but just so that you understand the wider framework. Sustainable delivery platform availability. So this is all about actually making sure that we have resilience built into our design from day one. We're exploiting technology, whether that's greater use of digital twins or RFID, whatever it may be. So this is all about making sure our equipment is available for greater periods, and that we reduce the support footprint for the equipment in the future. And the way we can influence that is things like, changing the defence standards that we have to procure to, DEFSTAN 51, thinking about the environmental parameters, thinking about the parts of the world we're going to be operating in the future, and the fact that our equipment will need to be more resilient by design to operate in that climate change world. Operational energy in the global transition, I've touched on this already, absolutely huge, of course. Now, this is now subject to a separate piece of work, which is actually a tender at the moment that's live, to write a defence operational energy strategy, sponsored from the MOD by the Director of Climate Change and Sustainability, James Clare, but delivered through defence support into my area through the Defence Strategic Fuels Authority. That strategy should help start really providing the direction of travel for our choices when it comes to hydrogen versus PV or whatever those choices will be in the future. Resilience of the global strategic base, this is very much focused on designing for sustainability in our overseas bases. You know, this is looking at places like Gibraltar, Duckham, Akrotiri. We've done climate analysis on those locations, working with Stratcom's Overseas Base Directorate, and really thinking about how we make sure that, I mean, when you look at some of the modelling that the contractors did about the climatic conditions, particularly in, say, the sea level rises for Gibraltar's airport, or you know the situation at Duckham with the amount of time that people are going to be able to actually load aeroplanes or operate during the day, because the number of times that you know the RAF mover is going to be able to load C-17s in the middle of the day in Duckham, that is going to get harder and harder as the years go on with the predicted climate changes. So it's really thinking about that global strategic base in our hubs and the resilience. Go into self-sustainment operations again in a moment. Defence commodities, this is all about scope 3 emissions, really, thinking into our value chain, contracting for more than just cost. In the future, this is reshaping the contractual environment and really believing that we can actually contract for carbon reduction pathways as well as just to minimise costs for defence. It's about redefining value for the taxpayer. Value for the taxpayer doesn't always mean the cheapest, and trying to get the levers pulled across policy and commercial policy in particular, so that we are looking at the world in a different way in terms of the value when we contract. And the impact of deployed food, one of my favourites really. Quite a niche area in some ways, because you're talking about, you know, ORP, ration packs, and a handful of contracts for overseas food. But we can be doing it better, and this is one that will appeal to the hearts and minds of our people as well, if we can actually think about the way we, you know, we feed our personnel. So we've got quite a bit of work going on to enhance the nutrition in the ration pack. We did some trials with the Marines recently, and at the same time to reduce the carbon footprint and to have choices in that operational food for our people, to make sure that the impact of deployed food is addressed, as well as the factors of changing dietary preferences and enhanced nutrition to improve capability, people capability on operations. So there's a whole load of stuff going on that's underpinning those 6 initiatives in my own area, just in terms of a small portfolio team and using our own defence support levers to reach out to allies, reach out to industry. You know, we do that through our partners with TDI as well, and these kind of events. And then at the bottom there in the light blue, that is James Clare's organisation, really, who are doing the really broad underpinning work that we all need to be able to take this forward. You know, proper granularity, better granularity in our carbon baseline, thinking about the scenarios we're going to plan to in our exercises, thinking about climate wargaming capability, and very importantly, literacy, behaviour and skills. You know, I think there's a real issue, probably preaching to the absolute converted in this room, but there is a real issue in defence. People go, well, green stuff, aren't we doing that by now? You know, and I've heard people say, well, James Clare, well, he's sorting that out, isn't he? Okay, there's a bit of a misunderstanding still about the amount of time it's going to take to really get this permeated throughout defence and part of our core activity. Success in my mind is when you don't need a climate change and sustainability directorate anymore. It's gone, because it's absolutely core to everything we do, and we're still able to be you know, at the leading edge of operational capability. That is the end of the path and the success. I am playing to the audience here. Everyone see this? Self-sustainment on deployed operations. So this is a great one, and this is one that I lead directly, and I hope from this conference I'm going to build some new partnerships in order to take some of these things forward into reality. But we see the opportunity, and I know you all do too. We can deliver on operations. We can remove the lengthy supply chains with high volumes of material flowing through them, and start thinking about that future base. I'm just going to read a direct quote here from General Wardlaw's note when he first put his thoughts down, because I think it plays to that ambition, even though we've got to have a gradual step towards it. It's no longer fictitious to imagine a battery-powered future force that recharges its own cells using deployed solar farms, prints its own spare parts, arms itself with rechargeable direct energy weapons, filters its own water, and even vertically farms its own food. And that's where ultimately we can take this journey. Of course, quite a number of steps on the way. So enhancement of military capability. We know that we'll reduce our impact on the environment. Of course we will, if we're using renewable energy and we're reducing the supply chains, just reducing the number of air resupply flights you need on your operation because you're existing in a self-sustaining location. And of course, designing in so that we are able to cope with the changing environment and reducing our reliance on fossil fuels in a world where eventually they will become harder to get, and our assets could end up stranded if we are still fully reliant on fossil fuels. And we do believe that there is cost advantage to this eventually, but let's do that with an open mind. People won't believe us if we say it's all free. Clearly there is investment, but over the long term, if you're not resupplying an operation over thousands of miles week in, week out, and that is allowed to be costed into your model, and that's important at the moment because the cost models don't often actually factor in those aspects which we all know are the hidden costs of the way we do business at the moment. So if you're mapping this against our conceptual framework through the integrated operating concept, what we did was think about, where do you start with this? Where do you want to begin? Now, starting with trying to convince, in a war fighting situation that sustainability is your priority, you're probably on a loser. But if you map it against the IOPSI framework and you think about in a low intensity, typically longer duration operation at perhaps the protect or engage end of the scale, you can have greater impact over a longer period, and your threat potential's higher as well, because you're going to be in the location for longer, potentially with more people exposed. So, and the opportunities in that, renewable power, of course, I'm going to talk in a moment about the work we've done on Mali. Food and water, the idea that you're going to go for local sourcing rather than flying everything in from Holland, as I think they do for Mali at the moment. And of course, thinking about your modal shift, thinking about, how you reduce your supply chains and the carbon footprint of your supply chains. So the AADP, is that so the Army Advanced Development Programme, we had 2 lieutenant colonels from there come and work in support of this particular initiative on the strategy, and I sent them out to Mali for a few days, and they went and looked at all of the energy in Mali, and have basically produced a sort of minimum viable product model to think about the how you compare energy, carbon and cost on an operation, and you could then provide that energy in a different way. Now, I'm not an engineer, and so I get very aware of the audience here and the fact that I'm not going to get too deep into this. But at the same time, the whole idea, and I know already that you're looking at similar models, you're looking at how you can take our models forward. But the idea is that we want PJHQ to be looking at those calculations and looking at that at the first stage of planning an operation, particularly if it's a deliberate operation that perhaps fits in the left end of this, where we've got the opportunity to perhaps take time to think about how we could do it better. We demonstrated that we could have saved quite a lot of money if we had put PV on the accommodation at Marley. It was rejected at the time because the cost balance case did not factor in the true costs. It didn't factor in the, I can't remember how many thousand miles supply chain of diesel that was coming across the Sahara. So, you know, those sort of areas, if we can get those cost models updated, we've got a chance of proving the value, the benefits from a cost, carbon and energy perspective, i.e. you can obviously ensure you've got that capability. So what next? So yes, we are going to write a defence operational energy strategy over probably the next 6 months or so, and we will definitely be reaching out to many of your areas for stakeholder engagement as we do that. Contract award probably in a month or so to take that forward, but my team in Defence Strategic Field Authority will be leading that work. I think it's all for me about shifting the focus beyond the UK base. Now, DIO are doing you know, a great job working on what's going on in the UK. That's probably the more mature area. That's where we're subject to more regulation because of UK government regulation. We're really thinking about that focus beyond the UK base. That's where defence support is at, and I know that's where many of you are at too. So we want to build on that model, that operational energy model. We'd like to run it through Opca Brit, for example, and compare it for a temperate environment where obviously PV, you know, isn't such a relevant solution potentially, and establish wider op energy baselines so that we can really then think about that triangle of cost, carbon, and capability energy as a balanced approach. We want to exploit opportunities in the Defence Exercise Programme. We've been speaking with the ARC already and with Army. I know General Wardlaw's engaged the new DCGS Army, and Patrick, General Sanders, also committed to trying to roll out some demonstrations of lower carbon capability on exercises. So we are really looking to follow that up. And in fact, that's a main part of what Imran's going to be doing, hopefully, in my team to try and pull that together. So, and yeah, we want to be that cross-cutting organisation that tries to bring some coherence and collaboration with those command initiatives. I run a thing called the Defence Support Force Development Board, which is all about trying to say, well, look, Army, you're doing some great stuff over here, but did you know the Navy are doing something very similar, and that we could actually bring this together? That's part of the reason Defence Support was created, because in the Levine model and the disaggregated defence that we live in, somebody still has to bring it back together to make sure that we are benefiting from each other's work and not obviously missing out on good opportunities. So yeah, targeted research and experimentation, some really exciting work out there. We're doing Rolls-Royce, for example, thinking about micro-nuclear capability for the deployed environment in the future. Amazing opportunity there that I know General Wardlaw is enthused about, and so am I, in terms of a self-sustaining base, if that can be something that is, you know, a future capability. So we're brigading those arguments and advocating from a support perspective that should be definitely looked into more seriously now, and working on those sort of areas. And in our industry engagement, it's one of our highest priorities that you know, thinking about sustainable solutions with industry, making sure that we are you know, working in lockstep, and particularly in the support area, of course. You know, we're not necessarily often inventing novel technologies. We're working on what industry is already designing, but then adapting it for military use. Thinking about the policies and the changes we're trying to make, and really understanding the second, third order effects as they cascade down, and where that brings risk, and you know, and how effective, of course, little sort of strategic policy levers can be as they cascade down when you are thinking about change and trying to make defence more sustainable. And ultimately, at the end of the day, you know, we want to be able to prove that the balance of investment decisions we make can be considered differently. And if we think about that full cost of operating versus just the cost of procurement, the sustainability arguments will be able to win through in a much more coherent way than they have done to date, I believe. I think that's probably enough for me. It was about 25 minutes. Was that about right? Thanks very much. look forward to the panel session later.
Thank you.
All right.
So I saw lots of frantic note taking going on in the middle of that presentation. So all these presentations will be available at the end, and we are recording them all. So if you haven't captured the information you want, we can get it to you later. Okay, so move forward. Okay, so to give the technical side, I'll hand you over.
So yeah, that was me. Good morning, I'm Lt Colonel Doug Nelson. I'm the CEO of InstRE Works Group. And for my sins, I'm the chair of the 170 Sustainability Working Group. Now, I'll freely admit that I am not an expert in sustainability, but I wanted to talk to you on the kind of journey that we have gone through as military engineers over the last 6 months, and how we are trying to understand our move towards net carbon zero. So what is sustainability? It can be loosely defined as meeting the needs of today without compromising the needs of the future. Sustainability is a vast topic and covers economic, social, and environmental. It's so much more than going towards net carbon zero. But I believe that as military engineers, the movement towards net carbon zero is our greatest challenge. And that's what I'm going to focus on today. When I first started looking at sustainability, I will freely admit I was overwhelmed. There is a huge amount of information out there. I thought many of the levers were outside of the military's control, and the task was pretty much unachievable for the operational estate. I'm pleased to say that I have done a 180. I was wrong. It is achievable, and we can start today. Okay, this slide is for the home estate and talks through and gives you some idea of the complexity of the tasks. How do we bound the problem for the operational estate? A holistic approach is required, and I spent probably the last 6 months just trying to understand it. It's important to understand where our emissions come from. So just bear with me if you've seen this before. Scope 1 is our direct emissions from what we build, how we operate, and how we generate our own energy. Scope 2 is the indirect direct emissions that come from the supply of energy from, in this case, because it's on the home estate, our national grid. And Scope 3 is the indirect emissions that come from things that are more difficult to track within our supply chain. Now, whether it's frozen. There we go. One of the constant frustrations that I've had when I've approached that is the tendency of people to focus on equipment solutions and showcase projects to show, we are doing something. Benefits are frequently overstated. True emissions are not really captured. And they're pushed further down the supply chain. Sustainability is popular, and there's seemingly no end to the amount of people that can solve the problem for us. However, what I've found is that the analysis is frequently only a PowerPoint slide deep. What we really need to do is not get after niche solutions, but a plan to reduce our carbon footprint overall. The technology is out there, we just need to work out how to use it best. So let's break it down. This is our operational estate at this moment in time. I've used what we're using in Eastern Europe, which is probably the most immature that we have. The Middle East estate has benefited from us being there for over 20 years and actually is moving towards more permanent tier 3 builds. You'll recognize the tentage from Afghanistan and Iraq. They're pretty inefficient and are past their use-by date. We only have approximately 1,200 bed spaces available to us at this moment in time, and that's based on legacy stock. It doesn't currently meet our operational needs. So we've been relying upon the Poles and Estonians to provide tentage for us. The accommodation is somewhat austere, not suitable for the climate and not an enduring solution. If 40% of our emissions on the home estate come from heating, can you imagine how much energy is going to get used in heating those tents during winter? We have therefore hired tier 2 cabins, utilising a contract with the NAFI to provide winter accommodation for our troops in Estonia. And that's what you can see on the right-hand side. Now imagine something like this, something with good insulation, is made from low carbon materials, incorporates renewables from the start, and has a high efficiency of fixtures and fittings. Imagine the energy and the money that can be saved from greater self-sufficiency. Imagine if we utilise this in Iraq and in Camp Bastion, how fewer combat logistic patrols we would need to have run. How many lives could have been saved by not running those patrols? The Americans have started to seriously look at this as a problem. The technology exists and the financial justification is more convincing than you might think to go straight to tier 2. So how do we get to a more sustainable estate? We need a systematic approach to focus our effort. The operational estate encompasses from tier 1 to tier 3 buildings from the Arctic, temperate, and desert regions. A one-size-fits-all solution is not appropriate and will not be effective. Before we can start, we need to understand the problem. Once we understand, we can then use efficiency savings, such as greater insulation or efficient components to lower our carbon footprint. We can then target what is left with renewables. However, we'll be left with an irreducible minimum that we can't cut. And this will need to be offset by defence. This isn't an excuse to do nothing, though. It just means we need to apply industry best practice where we can. Key to understanding the operational footprint has been the development of the operational and carbon calculator from the AADP, which was spoken about earlier. That was aimed at being produced for defence support and has been trialled at Op Newcombe and validated by Rolls-Royce. It takes every source of emission and converts it into an equivalent CO2 value. You will notice that there are a lot more emissions that are in scope than there were on the home estates. These metrics have been used to form the requirement for the next total facilities management contract in the broader Middle East. So we are already using the data from this trial that was published at the beginning of this month on using it on the operational estate. And I want to get the message across is that things are actually moving pretty quickly with regards to this. We've been stagnant for a large period of time, and now the momentum is building. Ultimately, we're hoping to instrument our infrastructure assets so we can understand where our greatest emissions are and where we need to focus our attention in the future. On the home estate, combined heating and power combined are responsible for nearly 60% of emissions. But at the moment, we simply just don't know what we're using on the operational estate. By capturing this data, we will know when and where we are using the energy, make people accountable for it, and drive efficiencies through better design and energy management. This will then allow us to use every bag of tricks that we've got to address the problem, okay? Once we understand the problem, we can find a solution that fits. Crucially, though, we'll be able to measure, our effect, what we're doing, adjust, and then move forward as a plan. Okay, we need to start building smarter too. We waste too much in military construction by not getting things right first time. and delaying key decisions such as a move to tier 2 infrastructure. We frequently make do and mend and put a sticking plaster on solutions rather than taking a long-term view. This far outstrips any benefit we can get from efficiency savings or renewables. As military engineers, this is made worse by our extended logistics chain. By embracing modern methods of construction, which is the industry standard, we guarantee our quality with factory-produced infrastructure. It is quicker, more efficient, uses less resource, and gets the quality right first time, every time. Crucially for us as military engineers, modern method construction doesn't have a high training burden to maintain the competency of a workforce. Fewer people will need to deploy forward, and they'll be on the ground for less time, reducing their exposure to risk and minimizing the resources needed to keep them there. While there are many valid reasons for using locally purchased raw materials, and I admire the rationale behind building to the vernacular, it is likely that many of the locally purchased processed materials will come from China, be of dubious quality, and come from an unknown carbon footprint. The COVID crisis has taught us that we cannot rely on global supply chains as we once did. With modern methods of construction, we can assure low carbon materials are used, such as low carbon cement. We can assure that the designs are safe and conform to the highest of standards, and we can assure our carbon footprint in our supply chain. As extreme weather events continue to rise, we'll see growing amounts of migrants and displaced persons. We have seen from Op Isotrope and Op Rumen that the government is keen to use the military to respond in a crisis. There is therefore the need to deliver more durable accommodation quickly, and unfortunately, tentage is no longer suitable for this task. We need to be asking ourselves why we are not optimizing for delivery of modern methods of construction projects. We need to explore contractually how we can employ modern methods of construction quicker to meet defence's needs, so that any new infrastructure is more sustainable from the start. Due to financial restrictions, we are unlikely to be able to hold reserve stock, so we need to exploit contract for manufacturing capacity in a similar way to how we contract for the Ro-Ro fleet, for example. Potential solutions could be the overseas procurement contract can provide tier 2 500 bed spaces at tier 2, or what we're seeing at the moment from the NAFI is they are keen to play a more active role in delivering services on operations. They've already delivered tier 2 accommodation in Estonia, and this is potentially another route to market. So let's focus on renewables. On the home estate, they're aiming to provide 30% of peak demand from renewables. But the home estate has the advantage of already being plugged in to an ever-greening grid that nearly 50% of their energy comes from renewables. I went out to some industry contacts to ask about the carbon and financial payback of renewables, and was told that most likely time to take to pay back our investment would be around 15 years. Initially, this ruled out using renewables on the op estate. However, recent trials in Mali have turned this logic on its head. With the added expense of logistics of getting fuel to the operational theatre, carbon and financial payback times have dramatically shrunk. With the long logistics tails of operational theatres, renewables are substantially more economically viable than on the home estate. A trial led by the Germans has managed to financially pay back the cost of solar panels within a year. With carbon payback being achieved quicker than that. Now, admittedly, their trial was only for 10% of their load, but estimates from the AADP study indicates that 93% of the power demands of the UK camp in Mali could be met from solar power and achieved by utilising the unused space, roof space within the camp. There are some limitations within the study, which has not been conducted by infrastructure specialists, but PJHQ are now keen for further trials on the operational estate to test what is achievable. We as military engineers need to be at the vanguard of these trials. Wind power has been shown to be slightly more expensive and can have tactical limitations. There's also a slightly longer payback, but with greater emphasis on northeastern Europe with Mobilise is probably the only viable solution for the north and the near Arctic regions. But what about future power demand? As much as we optimise our estate, there is increasingly going to be a demand for more power, for new autonomous systems, and for the next generation of fuel production. We are already seeing autonomous vehicles looking to be brought into Bahrain and increasing the load on the system, on the infrastructure at that location. Currently, emissions from fuels account for 55% of defence's emissions. We'll need to ensure that we have the skills to meet this future demand of the fuels and corresponding power generation required. Okay, hydrogen and synthetic aviation fuel. A large part of defence's carbon emissions can be directly attributed to air travel. While the CEO of EasyJet has stated he believes that hydrogen is the future of flight, I'm more inclined to believe the CEO of Rolls-Royce, who says that synthetic aviation fuel should be embraced as a stepping stone technology. Synthetic aviation fuel is manufactured by extracting hydrogen from water and carbon from atmospheric carbon dioxide and combined to create a synthetic fuel. With synthetic aviation fuel, we have the technology to make air travel carbon neutral now. SAF requires a lot of energy to make and is 3 times the cost of normal fuel. But if it is made using green energy, it is carbon neutral. Our King has insisted that every flight he takes using synthetic aviation fuel. Hydrogen technology in cars is some way behind electric vehicles, but offers a more credible solution for military means. JCB have developed a hydrogen piston engine for their plant that offers a glimpse into what future military vehicles could look like. Hydrogen can also be used in power cells, and the US military have already started trialling these concepts. From 2025, there will be no new gas boilers in the UK. Hydrogen is the only viable alternative to replace them. It is worth saying that, as alluded to earlier by Defence Support, any switch in terms of fuel needs to be agreed with our defence partners and NATO. So where does this fit in with infrastructure? Hydrogen and synthetic can be made almost anywhere in the world, as long as you have power, air and water. But they need vast amounts of electricity to make them. Imagine, though, the potential of a deployed force that is near self-sustaining. 2 potential power generation solutions on the near horizon are currently being developed. Small medium reactors. Small medium reactors are a bit of a misnomer. There seems to be belief that can be fitted into an ISO container and quick to establish. While parts can be transported in ISO containers, people need SMRs as modern and method construction for a nuclear reactor. They will be built in a factory by Rolls-Royce kits. There are a few football pitches in size, and Rolls-Royce estimate that they will cost approximately 1.8 billion each. While the electricity produced will be half the cost of current nuclear power, they are roughly the cost of an SU class nuclear submarine. For military use, these will need to be dug in and protected. Now, I'm not talking about shell scrape here. I'm talking about the same level of protection that you need for a nuclear bunker. This would be a major civil engineering project. It would take potentially 2 to 3 years to design and construct. Consequently, I do not see SMRs being deployed within an operational theatre. Rolls-Royce plans to construct up to 16 SMRs in the UK. Well, the first SMR will start in 2029 with a production rate of 3 to 4 SMRs being produced every year. Once completed, they can provide 400 megawatts, which is enough to power a city the size of Leeds. SMRs are potentially a more sustaining option for post-conflict reconstruction or hydroelectric aviation fuel outside of the operational theatre. Geothermal. Geothermal energy is undergoing somewhat of a renaissance. While it's been traditionally used in fault lines to produce heat, the UK's first geothermal power line this year. The problem with traditional geothermal is that it's geographically limited and the success of both runs at about 20%. New deep drilling techniques are being developed to see us exploit hot rock energy from deep inside the Earth's crust. This will allow us to generate geothermal steam using traditional turbines anywhere in the world. Geothermal power is mostly underground and doesn't require a great deal of real estate to operate. Legacy fossil fuel power stations could be repurposed and turned into green geothermal power stations. This could potentially provide between 10 and 100 megawatts and can be constructed in a fraction of time of an SMR reactor. The first full-scale hybrid drilling rig we need a plan of action. The carbon calculator needs to be rolled out across the operational estate and trialling the use of renewables on a larger scale. We need to use this data to generate a sustainable estate development plan for each theatre and a roadmap to how we get to net carbon zero. This will allow funding to be secured and a programme resourced accordingly. We need to exploit this conference to forge closer links with between the Royal Engineering Working Groups, the AADP, DSTL, and industry. This will allow us to exploit best practice and new technology quicker. Too often, defence's approach has been disjointed and confined to niche areas. There's some real great work that's been going on that we could all benefit from, and if we work together, we can achieve this faster. Simultaneously, we need to explore contractually how we employ modern methods of construction quicker on the operational estate so that any new infrastructure is more sustainable from the start. Finally, I will reiterate, I am not an expert on this. I'm really looking forward to listening to the presentations here and speaking to as many of you as I possibly can over the next couple of days. Thank you for your time, and I look forward to your questions. Thank you.
So thank you for that. So I'm now going to hand you over to General Nugee, who's going to give you his new role in InstRE and opinions on some of the presentations this morning, but his own thoughts.
Thank you very much indeed. I don't have any slides, so you'll just have to listen to me. Apologies for that. I suppose what I really want to do, an industry response, gosh, what a title when a lot of industry is here. But I suppose the first thing I want to do is say thank you. I almost feel like just sitting down and saying job done, in the sense that things have moved on very substantially from 2 years ago when I started, when frankly, the defence was not taking this seriously. I was told that my report was not necessary. They even refused to pay for me to do it, and the army very kindly stepped in and paid for my salary while I did it, because defence just wasn't interested. I think we've moved on very, very substantially since then, and a huge thank you. Also, thank you to the engineers. Actually, if you think about it, engineers typify what the military do brilliantly, which is to adapt to the environment. If you go back 100 years, 200 years, long before oil, what you find is engineers building buildings for our troops that were naturally cool in India. High ceilings, big rooms. It wasn't to show off that they could do it, it was to try and cool the rooms. So actually this comes completely naturally to the engineers, to try and embrace the environment. The difference is the environment is changing faster than we realize. And so we have to adapt much more quickly. And the engineers, I can think of nobody better than doing that. I wanted to pick up a couple of things that have been said already. I'll disagree with one or two things, if you don't mind. But one of the things that Ange said, which I think is absolutely right, this is about military capability. Her sort of comments, outpace, outwit, and outfight, which I love. The idea is actually, this is not about reducing our capability. This is about increasing our capability. This is about doing more with the same. This is about being better than our opposition. This is not about addressing a green agenda for the sake of the green agenda. And however many environmentalists may be disappointed by that, it is the fact for the military. We've got a job to do. Our purpose doesn't change. For some companies, the environment is existential. That if they don't get it right, their customers will leave them. I can pretty much guarantee that for the last 2,000 years, there will be an army in 2100. There will be a navy if there's still some sea around in 2100, and there will be an air force. They will look fundamentally different to today, without a doubt. But the fact is they'll still be there, because we'll still need to protect whatever it is we feel we need to protect. And it's interesting, there's a book called Move, which is all about migration, which I've just read, which posits the idea that armies will come together under the United Nations in about 30, 40 years' time to defend those parts of the world against environmental damage. So you can imagine, this book said, in 30 to 40 years' time, armies going off to the rainforest, the Brazilian rainforest, and defending the rainforest against the Brazilians, against anybody who wants to defeat it, because that's the way the world will have gone. Now, I'm not sure I agree with that, but the very fact that people are writing that in books suggests that there's some thinking about how we're going to be using our militaries in the future, which may well be to defend what is critical for the planet. One of the other comments I make regularly is don't mention emissions when it comes to military. Don't talk about emissions. Don't talk about how much carbon we're going to save. Of course, that is what we're trying to do. But phrase it in a different way. Phrase it about cost cutting or saving money, which is what Andrew was talking about. Phrase it in a word that I haven't heard this morning so far, in terms of resilience. If actually we have our own supply of energy, we are more resilient than those who rely on somebody else to provide our energy, because that can be cut off. And so it's all about actually building resilience as a force. Napoleon famously said an army marched on its stomach. What he meant by that is wherever it went, it found food. It was completely self-sufficient. They hadn't really sort of worked out logistics in those days at the same level. That's what we've got to be. I'm not suggesting we just take food from everywhere. What I'm suggesting is we should be as self-sufficient as possible, because we are resilient as a force by doing so. And then the final point, the sustainability lens, and this has been talked through twice now. Sustainability lens is about looking for opportunity. It is not about looking for the problems that might come. There are problems, of course, but it's not an imposition. So, going back to where I was going to start, I suppose, an industry response. Well, I think there are 5 general sort of principles that are coming out of what industry is doing and what I think we ought to be looking at. The first, and it's been mentioned, is efficiency. Sustainability equals better efficiency. And what that means is reducing demand as well as providing an alternative supply. It's not just about providing an alternative supply, it's about reducing demand as well. Where you can reduce demand, that is a more efficient way of doing business. Efficiency regularly results in lower cost and can result in lower maintenance costs and lower maintenance budgets. Richard Wardlaw, who's a great friend of mine, who used to work for me, he turned around once and said, actually, do you know what? The Navy's response to an increase in the cost of fuel is to tie up its ships. We always used to do that. It's just tie up its ships. That way you cut the amount of fuel that it's using. Of course you do. He said, wouldn't it be better if actually the response was to have a more efficient ship so you could still keep it at sea and then you're still doing your job and you're reducing the amount of fuel. So lower cost, lower maintenance. How do you do that? One of the most interesting things that I've learned talking to the Navy and the Air Force is about near misses. So the Air Force, every single element of an aeroplane is monitored. Every single element. There's tons of information coming out of the engine. There's tons of information coming out of the electric. Can we do the same? The Navy does it to a better extent. And what you get from that, the Army, sorry, doesn't do that. Let's just be really clear, to the same level at all. What you get from that is an understanding of near misses. So a catastrophe hasn't happened, but they've noticed something going slightly wrong. And therefore they investigate it and they work out why. Near misses, understanding near misses brings efficiency. Wouldn't it be brilliant if all the vehicles in the Army did the same as they don't at the moment? So it's monitoring. It's building digital twins. Now, digital twins, I was having a go at somebody last night about digital twins. What is digital twins? Well, it's a fancy new word. We've been doing it for years. It's called modeling. It just happens to be digital and it happens to be interactive so that you're getting in information and you're reacting to that information. So it's not passive modeling. But actually, if you can build a digital model that interacts, you can start to see where the problems are. This is what smart meters do in your home, in very simple terms. What they're doing, what a smart meter does, and I have one of these. I suddenly found a huge spike at 3 o'clock in the morning in my electricity, and I had absolutely no idea why. So we looked at absolutely everything. Why was I getting at home a massive spike at 3 o'clock in the morning? The answer was really clear, as it turned out. I wanted a nice warm kitchen to come down to at sort of 8 o'clock in the morning, and my underfloor heating was spiking at 3 o'clock in the morning, massive spike of electricity to get my underfloor heating. So I came back down to a nice warm kitchen. Turn off the underfloor heating, the spike disappears. So I found an alternative method. So actually, digital twins are really useful. Second one, optimize for supply and demand. Reduce demand, but optimize for supply and demand. All our systems traditionally have been optimized for either supply. Take generators on a battlefield. You turn the generator on, broadly speaking, it stays at the same speed throughout. Why? Because you're optimizing it to try and cut the fuel that you need, because you know you've got to bring it in through logistics. So you keep the generator on at the same level, regardless of how much the headquarters needs. So you've optimized it for supply. If you were intelligent, you'd optimize for supply and demand. Now, in order to do that, you need a buffer in between. It's really simple. It's called a battery of some sort. And there are all sorts of different types of batteries that you can use. But try and find a way that actually you optimize for demand, so you only use the electricity that you need, and you optimize for supply, you produce the most efficient amount of electricity that you can. Those are never going to meet up, or very, very rarely meet up. So you need something in between. And providing something in between allows you to surge without having to turn the generators up, or whatever it is. Thinking like that, and it's what effectively microgrids and things like that do. It's what effectively you're trying to do is optimize for supply and demand. If the country optimized for supply and demand, actually we'd be in a much better place. But our storage in this country, at a global level, if you like, is tiny. And therefore we don't. What we actually do is optimize for peak demand, and any electricity we don't need, we actually give away. Now that's great for companies that, like Octopus, that can use that, and they actually give you electricity for free if you have a battery. But that's not very clever. We should be doing that at a global level. We should certainly be doing that on operations. Third thing I would say is think how to minimize the supply chain. We have absolutely heard already about combat logistic patrols. So a few figures on that. The Americans reckon they lost 2,000 to 3,000 troops on combat logistic patrols. We lost our most senior British officer in Afghanistan on a combat logistic patrol. Interestingly, he was an infantryman. He was CO of an infantry regiment. What on earth was an infantryman doing on a combat logistic patrol? Well, the answer is in the word combat. Actually, they had to fight through those logistics. So it isn't just saving blood and treasure. It's about the fact that actually that combat logistic patrol, as all of them did in Afghanistan, had aviation above, attack helicopters. It had armor out front, and it had infantry protecting it. They should be taking the fight to the enemy. That's what we do with aviation armor and infantry. They weren't doing that. What were they doing? They were protecting logistics. We're denying our own capability just for logistics. So yes, there's blood. Yes, there's treasure. But actually, there's military capability as well. And if you minimize it, then actually you get a much better outcome. So how can you do that? We've heard about solar. We've heard about nuclear. The slight disagreement, I would say, is that actually Rolls-Royce is producing a nuclear generator in a 40-foot container, ready by, I think, 2028. But Rolls-Royce will acknowledge that. It's about that. It only produces 5 megawatts, but it produces 5 megawatts for 5 years without refueling. And the fuel, and I'll get technical for a second, is a thing called a tri-structural isotropic. What the hell does that mean? It means that the little nuclear bit in the middle has 3 layers of protection. Try whatever. So 3 layers of protection, which means that it's basically a protected fuel. Even if you put a missile into it, it would not produce a nuclear explosion. So that actually they've thought through how to do this for the benefit of getting energy into an operational environment. Is it cheaper? It's not cheaper than electricity in this country. Is it cheaper compared to the amount of cost it takes to get diesel to, let's say, Helmand? Yes, it is. The Americans reckoned it was $500 a gallon, so that's 4.5 liters. We reckoned it was about somewhere between 180 and 200 pounds a gallon to get a gallon of diesel, 4.5 liters of diesel, to Helmand. Frankly, if they can produce a nuclear power that's cheaper than that, that would be good. There are others, ammonia, methane, sustainable aviation fuel has been mentioned, 3 times more expensive. Why is it more expensive? Because if you're going to produce green sustainable aviation fuel, you need green energy. Green energy is at a premium at the moment, and therefore it's much more expensive. SAF will become a thing of the future if we've got enough green energy to be able to produce it relatively cheaply. So I think that is an option. And there'll be a land equivalent, because frankly, there's almost no alternative to driving a 70-ton tank, I'll come back to that, than some form of sustainable fuel. Hydrogen won't do it, I'll come back to it. Think about water. So we've had fuel, water, recycle it. There's a thing called upfall showers, where you recycle 90% of the water in the shower. It's actually quite clever because you recycle it so fast that it doesn't lose its heat. So you reduce the amount of electricity needed or power needed to heat the shower, and it just goes through a small filter, and you use 90% of the same water. Actually, it's a really, really simple solution. Why aren't we doing that? It's easily deployable, and they're selling them all over the place. You've got condensing from air. The technologies exist. I don't think it's very good at the moment, but it will get better. MIT have just produced a portable desalinator that you can put on the back of a truck. That's a revolution. It's only come in the last couple of months. It's something that we should be looking at in order to try and make sure that we don't have to bring in a whole load of water if we are near to salinated water. Food. We've heard about vertical farming, 90% less water for leafy greens. I'm a little bit skeptical at the moment. It is quite delicate stuff, and you need quite quality people. Richard Ward was really keen on it, so good luck to him. But actually, fine. But actually, the opportunity that might be presented by that in the future, isotropic food, is something that we should be going for. Parts, 3D printing. Why aren't we doing 3D printing if we can? Again, reducing the amount of logistics coming down the logistics supply chain. You can't 3D print everything, but that which we can print, why shouldn't we? And then waste. Can we recycle? Can we reuse all the waste? I'm very impressed by His Majesty's Naval Base, Devonport. They've got a waste plant there that is producing all their heat and all their electricity. They take all the waste from the Portsmouth area, and in fact wider, and burn it at 800 degrees. It's so hot that most of the toxins are burnt out, and they produce enough heat to drive turbines to drive the electricity that the base needs, and enough heat to heat the base on a district heating system. And it's literally just across the road, built specifically for them. That's the sort of thing we should be thinking about. Now, can you do that in a small way when you're deployed? There must be sorts of things. Next, I'll talk about is, so we've had efficiency, optimize for supply and demand, think how to minimize the supply chain, think design, materials. Think materials, don't just take traditional materials. So Reds 10 that was mentioned, building these fantastic new buildings on our training estate. I went to the opening of the first one. Lovely building, not quite net zero. I think it's sort of 7 on the scale, if that means anything to anybody. And I just happened to mention to the boss, the CEO, I said, I said, there's an awful lot of embedded carbon in this building. Carbon to make the building. And he makes them all modular in his factory. I said, do you think you could reduce that? And it was an offhand comment that generals make that never really taken seriously, I thought. He came back to me, I opened the buildings at Nestcliff, which were the 2nd generation buildings. And he said, I took you at your word. And I thought, oh shit, sorry, oh dear. And he said, I've reduced the embedded carbon by 1/3. But the most interesting thing is it reduced the cost by 20% by looking at new materials. What's the net effect? I put that 20% into solar power. I put that 20% into making the building more efficient. It is now a net negative building. And actually it gives back to the grid more than it takes. What did they do? What did Nestcliff do with the money that was going to be used to run that building? They made all the ranges electrified. So what you got out of a better building, a net negative building, or net positive, however you want to describe it, is actually better military capability. A really direct sort of correlation. I think that's really exciting. So think about materials. Think about digital twins. Work out how you can use a model to try and get the best idea. Think about, going back to materials, think about what other alternatives are out there. There's a company called Armour, and I'm not a particular fan of making sort of particular companies, sort of talking about particular companies, but this is called Accessible Recyclable Material Accommodation. Well, sorry, Modular Accommodation, Armour. The buildings are made of 26, they're a bit like the buildings that are going up in Estonia, and I have every intention of talking to the NAFI tomorrow about this. They have, the buildings are made of 26,000 recycled bottles each. They're 98% recycled. But actually, what are the properties of plastic bottles when compressed and all the rest of it? They are better for insulation. So it is a more efficient building. It's lighter, because plastic's quite light. So it weighs only 2 tons and can be taken underneath a Chinook. It actually is much better to live in, because it slightly flexes. So here's an idea, which has come from somebody, God knows who can use recycled bottles to make our buildings. And they last, they say, for 200 years. How they can prove that, since they only started making them last year, I don't know. But they say they last for 200 years. But for me, it's not so much that particular example. It's the ideas that are coming out of this revolution about climate change that are worth looking at, rather than just assuming that the materials that we've used before are the materials we should use in the future. Build things modular, if you possibly can, in the environment, because things go wrong, things break. If you build them modular, you can use, and therefore you can reuse, recycle, repurpose. Understand the supply chain. This was briefly mentioned. It's got a lot of press this morning, actually. How much of our supply chain is reliant on China? How much of our supply chain is reliant on Europe? And funnily enough, we're not in Europe anymore, in the UK. How much of that supply chain can we onshore by thinking of different materials and different ways of doing things? And actually, I think we're particularly vulnerable in the military. We did it when we were trying to work out how to deal with Brexit. So back in 2016, we did an analysis of all our supply chains, and we asked our primes to do an analysis of their supply chains. And guess what? They couldn't do it. They couldn't work down to the 6th, 7th, 8th level. And they found that almost everything had a European part somewhere. And they were going, oops, this is going to cause us problems. And so actually understanding your supply chain and trying to make it onshore as much as possible. And I am genuinely worried, as somebody in the press was this morning, that 80% of the refining of rare earths is done in China. What would I do if I was Chinese and I wanted to take us over? What I would do is give you everything possible and then turn the tap off when you're stuck. That's the best solution. So actually just accepting everything from China and hoping it's going to be okay is a strategy, but hope was never a very good strategy. So actually thinking about our supply chain, where does stuff come from? How do we make it here? Building innovation in this country, as an aside, is something that we should be doing. 80% of the effect that you can have on climate change and carbon and sustainability is in the design. So think about it. And operational design is changing all the time. We've heard about those buildings that the NAFI's putting up in Estonia. And I'm going to talk to them again because there's another piece, which is actually think about how you lay out the buildings. And this was a conversation actually last night. I don't know how many of you have been to the hospital in Birmingham, the hospital where the military have a wing in Birmingham, the Queen Elizabeth Hospital. Brand new hospital, fantastic building. They realize, and I'm talking about design here, they realize that actually straight lines and mental health don't go together. Bad mental health don't go together. The idea of one massive long corridor with beds all the way down it, with the nurse or the talking to the top or shouting all the way down to the other end, it's appalling for mental health issues. So what they did is they built every single ward in a leaf shape, in a sort of oval like that. So there's not a single straight line on that blooming building, because the leaves are in a curve. They come out of a curve. Think design. Think how much actually that makes a difference. In that case, in mental health, but in terms of how we put our buildings together. So it was being described yesterday, if you just put building, 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 you get much less of an impact than if you build buildings in quads, or build buildings close enough to each other that they retain heat when you want to retain heat, and far enough away that they actually they don't retain the heat in very hot conditions. Engineers should be perfect at this. They should be brilliant at this. They should be able to experiment with this on operations. And I think you do regularly, to greater or lesser good, but you do regularly. But actually think about passive cooling, passive heating, because of the way you've designed. All about energy reduction, all about reducing your supply chain. And there's one piece here which it can be misinterpreted, so forgive me. But actually look at local solutions. Don't necessarily buy local, but look at local solutions. How have they solved the problem? Because they've probably been there longer than we have. And they're probably, therefore, more attuned to the environment than we are. And therefore, think about how they do things. Take the, if you like, the kernel of what they're doing and work out how can we adapt to that, rather than just assuming that what we build in the northwest of Europe is going to be good for the south of Africa, for example. It's just not necessarily going to be the case. We don't always have the best solution. Sometimes those best solutions come from elsewhere. My final sort of principle, if you like, is start, don't just advise. I use a cliche regularly, which is if you're not on the pitch, you can't score a goal. You've got to start somewhere. We'll get it wrong, but start somewhere. Don't just look at the problem. This is my one slight problem with doing lots and lots of monitoring and lots of making sure we've got our baseline. There was a great phrase in the chief's office when I was with the chief of defence staff and all the chiefs around the table. If somebody asked for more information, what they were really doing is saying, I don't really believe in this. I want to delay it. So I'm going to ask for more information and more information again and more information again. Well, a little bit of monitoring what we're doing with our carbon is the same. We've got to understand it at the base level. but we don't need the nth degree to each carbon molecule. And there will be some who will encourage you to go to the nth degree to the last molecule, because actually that's a way of them possibly making money out of it, but more importantly, giving them a firm baseline. You don't need a firm baseline to the nth degree. You need a baseline enough to start and then start. And by goodness, once you start, you will learn really quickly where your carbon is coming from. It's like my smart meter and my spike in my electricity. But also, there are technologies out there we can adopt immediately. Additives into fuel. There's no reason why we shouldn't be adding fuel, additives into fuel in terms of our diesel already. Hybrids. So I said I'd come back to the tank. I attended a conference, it was a stimulating conference of the Armored Fighting Vehicle Energy Sustainability Conference, the first of its type, just like this is the first of its type. And I had Ryan Mattal describing how you would make a 70-ton tank sustainable. So they went through all the options. Full EV, fantastic, but the battery would weigh 23 tons more than the tank. And also, by the way, you'd need a tank that was 15 square meters, cubic meters, just to produce all the battery. So full EV, not a good idea. Hydrogen. If you're really happy to put the most explosive just about energy on the outside of a tank, because you couldn't fit it inside, you need twice as much volume on the outside of the tank for hydrogen tanks than you do to run the hydrogen fuel cells, than you do diesel. So not a terribly good idea, actually double the size of the tank, but also you're putting a hugely explosive piece on the tank. So not a brilliant idea. But what they have worked out is the very best type of drive on a tank is an electric drive. Anybody who has an electric car will know that once you put your foot on the accelerator, you disappear up, it's a bit like Back to the Future, leaving scorch marks behind. It is extraordinary. My son was blown away when I just put my foot to the accelerator, 0 to 60 in 3.5 seconds in my car, and it's not a sports car, it's electric. Tanks, they reckon they can get to 0 to 30 miles an hour in about 20 seconds, 30 seconds in a hybrid electric tank. So hybrid drives are the answer. How you fuel those drives is a different matter altogether. And by taking out some of the mechanics, what they found is that you can reduce the size by 2 tons and by 1 cubic meter. So hybridity is something that you could do today, you could do now. Why don't we do that? It's not the whole answer. We don't need the whole solution. There's no silver bullet, absolutely right. But actually, it offers us an opportunity. So I suppose in summary, I would say take advantage of modern technology. It's moving, so should we. And industry is at the forefront of this. But we shouldn't wait for industry in every case. We should be demanding from industry certain areas that we think we can do better and that we need their imagination and their innovation. But I wanted to leave you with an example, which is how do we produce baseload energy in this country? And it's not directly relevant to deployed, but I think things will get smaller. Baseload energy and domestic heating counts for some, I think it's 70% of the emissions of this country. So if we can provide a solution to that, we can really do well in this country to get to net zero. You've heard about solar. What was the announcement? 4 times, the Labour Party yesterday, 4 times as much solar as we have today. You've heard about wind. We're putting gigawatts of wind into the North Sea. Anne showed me her app, I must get it, showing how much of our electricity comes from renewables or where the mix comes from. When she showed it to me in the pub last night, 51% of our energy was coming from wind in this country. That's extraordinary. If we build on Dogger Bank, if we build all the way up the East Coast, actually, not only have we got the largest wind farm in the world, but it is actually achieving. Hydro. I think we should relook at hydro, how we can do it. We've got streams all over the place on the defence estate. We've got big rivers. Why can't we use hydro? It's much more sophisticated than that. Hydrogen. The government's going massively into hydrogen. Hydrogen's a slight problem. It's very explosive. It's a slight problem. It burns without you seeing it. So you get a burning hydrogen, you can't see it, and that is a real problem. Molecules are tiny, so it leaks. We'd have to put new hydrogen across the whole country to get our 20%, which is the maximum they think you can put into our boilers. It's an interim, it's not going to solve the problem. You still need 80% gas. And hydrogen for trucks, really good idea. Hydrogen for cars, not sure. I think the jury's out and the country's gone EV. And then finally, geothermal. And those pictures of geothermal were wrong in one respect. And that is closed loop monobore. It's a single well down. It's not two wells down, it's a single well down. You don't need to hit anything except the heat underneath our feet. And the net result of that is you have almost unlimited heat. Now, geothermal's an option, but all of them are in the mix. We've got to do all of them. We've got to do all of them, particularly if we need to produce enough renewable energy to make SAF cheap enough to be able to use by the Royal Air Force. This is happening all over the world. It's not just us. To go back to the deployable, and I'll finish. If we think through a sustainability lens of every way we can reduce the amount of combat logistic patrols or logistic patrols that the Air Force has to put out there, that the Navy has to put out there, that the Army has to protect to get there, then ultimately we will be better as a force. And we will be cheaper as a force. And we will actually be saving the planet at the same time. But that's almost oh, that's interesting. What we should be doing is looking for better military capability. I'll stop there because I think I've overspent my time.
Thank you. So you'll be happy to know it's coffee break. But just before we go, I just want to leave you 3 thoughts what I picked up from there, what would be good to think about in the time we've got in there. It's one, it's been mentioned a couple of times, thinking from the past. You don't know the Institution of Royal Engineers as a historical society, and we look at things in the past. But one example is Napoleon put trees down his roads so his armies could march in the shade, so they could go further for longer in better conditions. So can we live in the shade? Can we put solar panels above our buildings? Can we do things to live in the shade and not market it? What can we do today? What can we do today? So if you look around, some of the studies the institution's done are out there. One was mentioned earlier on, cement. We've done one on insulation. The insulation the British Army buys, its general insulation, is the worst insulation impact in the world. Can we just buy something else? Okay. And then looking towards the future, where we operate, people live there for a lot longer than we've operated in. Can we learn from what they do in them environments? Right? Our technology is not always the best. And when we go somewhere else, can we learn from what they do to operate better in that environment? But anyway, I'll leave it there. Hopefully, go and have a brew, go and have a chat. Please be back here for 10 to, and we might start a little bit later. Thank you.
If I want to go over and above the headroom on the magic money tree, even though I've got to go through all my business cases and everything, but if I want to exceed that headroom, I have to ask for more money and I have to justify that as an additional process along this line. We work very closely with our delivery agent, DEMS. And the reality is, we're the program and project managers and they're the delivery agent. They're working with industry to deliver that project for us. And that is a massive sticking point as well in the fact of resourcing at DEMS. We can have the money, and I'll show you this with some of the projects I've got, and the project, in my opinion, ready to go, but we've got nobody to deliver it with us in DEMS at the moment, and that puts the project on hold. And that's been happening a lot lately. And then we come back to prioritization. What is more of a priority? Is it the GMPP Boxer program, or is it maneuver power? And where do you think the political will lies, etc., with all of that as well? So within the programs directorate, within the Millenge department of that, and this has been slightly jiggled around through the Army Operating Model Review. This is what we cover. Now, I look after 2 of these programs. I look after Deployable Infrastructure 28, and I look after the next generation of wide gap crossing capability. We have 2 other programs. Some people I've talked to in the room today have been involved with them, and that is ME Combat 28, and that is the delivery principally, now what's left in it, of bridging equipment. And that's seen the delivery of the replacement for the MGB and MGCC. And if you looked at it side by side, you would not be able to tell it apart. It's because it's made of a new type of metal that isn't subject to stress corrosion cracking. And it's going to bring in a big project called Project Tyro, which is going to look at our general support and close support bridging. So the replacement for our BR90 bridging system in reality. And that is very close on the GSB side to go into contract, and not, although the decision has been made to go down the boxer bridging variant, as opposed to the replacement for our armoured bridging, there is still a component of armoured bridging that sits there. And there's also things like safety systems for bridging, so people don't fall off a bridge when they're trying to make it. I think we can blame one individual for that, whose son was joined the Royal Engineers just at the time. There was a photo of someone walking across a medium girder bridge in America, I think it was, at about 200 foot in the air with no safety equipment on. That's because that's how you build a bridge. And she went, we're going to put a safety system in place for MGB. So that fell into it as well. And there's some other little projects like the underwater boat gun, etc. wrapped up in that. They're bucket programs, very much these programs. The Counter CBRN project sits, actually it's an Army lead for a STRATCOM project or program, and that's delivering around about 17 different bits of CBRN capability. It's not delivering new vehicles like Fuchs vehicles, it's delivering respirators for Merlin helicopters, etc. It's that sort of level. The replacement for nerve agent treatment and maps and combi pens and the like. And then you've got my 2 in the middle. Next generation wide wet gap does exactly what it says on the tin. We're looking at replacing what is our current capability, which is the M3 rig, with a replacement platform. That is capable, however, of taking MLC military load classification 100, because that is what Challenger 3 plus M1 Abrams is over and above MLC 85, which is our current capability. Plus the M3 rig is very old. It's been through a midlife upgrade. It's coming to the end of its service life. And I'm now going to take you more into the one that we're really relevant to today's talk, which is the Deployable Infrastructure 28 program. Again, this was started life very much as a bucket program. When the support, as it was, and the integrate team were formed from what was that big CAP Army headquarters team, all of these projects were swept up. So unsurprisingly, some of these projects are old, and some people would go, my God, are you still looking at that? Because, for instance, Maneuver Power was first came about in 2009, the requirement for. CWSS, I think 2014, so some very old projects there. But extensively, we've got 5 projects left in the program. I say left because one of the programs we handed back last year, one of the projects we handed back last year, it wasn't required anymore. It has been kicking around for that long. And I'll cover each project in turn, but extensively, we've got one that looks at plant, one that looks at power, one that looks at water, and 2 that look at shelters. So I'll give some good news first. I'll give you the 2 contracts that we've got in place and are physically delivering at the moment. So Project MITRE, for those that wear green or have worn green before, will be aware of the C vehicle PFI contract, which delivered construction plant basically for, in the main, Royal Engineers. It's replaced that contract, but also incorporated the contract that looked after mechanical and handling equipment and the contract that delivered protected plant. So diggers with armour on them, for want of a better term. Amy Briggs won that contract. We're now coming up to the full service commencement of that contract, so about 2 years in. Got a year of parallel running when all the contracts were aligned. Then we hit the initial service commencement. That was a year ago. FSC is the end of this month. There is still some way to go on this contract in delivering it. There's an element we've introduced to the whole force approach. So it delivers sponsored reserves. There's 71 sponsored reserves under this, which are delivered over a 4-year period. And obviously we've got some issues around national recruiting, etc., and getting individuals who have not served in the military before, whether be that reserve or regular, through that process, trained, and then able to deploy as sponsored reserves on operations. And we also have a condo element of it as well. So we can deploy Amy Briggs personnel wearing blue coveralls pretty much anywhere in a benign environment around the world, which really does open up the scope for the likes of the works groups who are doing design, because whereas before we may have been constrained to a green bit of equipment for a lifting operation, which meant that you design your building to have more columns because they've got shorter beams because they weigh a lot, and you need to lift them into position. Now I can have longer beams because I can have any crane that I want, order it in theatre, and Amy Briggs will send me an operator out. I'll pay for it, but they'll operate that crane and do all the lifting operations, pump the beams down for me, and then go out. Okay, so we have that capability now. So a good contract. And there have been savings to defence, of course, from aligning 3 contracts into one. And it's a tri-service contract, so it affects your enemy as well. And also, it's actually quad service because it also covers defence munitions as well. You use certain lifting equipment to move munitions around. So a good news story, good news contract. Amy Briggs in place. Apart from the sponsored reserves, few hiccups there. We're moving along at pace with that contract. I'll very quickly mention I've got there, it's a Cat A project, and you'll see on these slides, this one, for instance, says Cat C. So the way we categorize our, without me telling you how much the contract is worth, although you can Google that because it's been awarded, anything, a Cat A is anything above 400 million. A Cat B is 100 to 400. A Cat C is 20 to 100, and under 20 is a Cat D. And that's how the projects are financially prioritized. TWSS, Cat C, around about 41-ish million. Again, what contracts already awarded. KBR won this contract. And this will touch on some of the areas that was covered this morning, actually. It is delivering combat water supply systems to the Royal Engineers. Extensively, that means defence, because if you want water, you call them sappers to get you water. Might be delivered by the RLC or delivered in the back of a plane in bottles or whatever it is, but it's got to start somewhere along the line. We are delivering 3 separate systems. A modular system, which is already in service with the Royal Engineers, fully fielded, which delivers in normal mode about a cubic metre an hour, in RO mode about half a cubic metre an hour. You don't need to have the RO module in place. You can take it out and it connects up and it just runs through. So you don't have to go through the RO mode. It actually works, unlike the WPU MBC, those that will remember it, which is a good thing. It's quite power hungry. If you put the RO module into it, you have to up the generator to a FEX size generator, which is a bit of an issue. It's quite heavy. We've had to design an arm so it can get manually lifted onto the back of EPLS vehicles, etc. But it's a good bit of equipment and it does what it says on the tin. There was some teething problems, it froze because the pipes weren't lagged correctly. We've worked with KBR, we've got over those teething problems, and we get good feedback now from the end user, principally 8 Engineer Brigade and SAPA units, from exercises that we're able to work with KBR and develop that product and the other 2 products which are coming down the pipeline. We're also delivering a containerized system, a much bigger water treatment plant. Will deliver around about 100 cubes a day. So it's sort of divisional level water supply. And that is a full RO plant. That is, you can chuck that in the sea. It'll do desalination, everything. It automatically, once it's set up, automatically back flushes itself when it needs to. It does everything that it's supposed to. And that is about 5 miles away from here at the moment, just about to start trials next week over at Upton Hard. So we're into the trial stage for delivery of the first piece of equipment into service next year on that. We're buying 20 containerized systems. They don't just come in 120 ISO containers. There's several ISO containers, about 6 in total. It comes with its own generator as well. And you can join them up when you put them into the next bit of equipment, which is the packaging plant. So all those that remember the days of Camp Bastion with the water bottling plant, Marley buying bottled water, flying it in, you don't need to anymore. You can connect the containerized system to a borehole, so we can involve 521 InstRE, and then we can put it through the packaging plant and we can package our own water. And it packages it into bags, not bottles. So there's a lot less plastic going into the packaging, and we don't have to get rid of it. There's not so much to get rid of at the end. The bags come in different sizes, 250, 500 and 1 litre. You can stand on top of them and jump up and down. In the main, we did burst one, but we think there's a bit of grit underneath it. But yeah, they are pretty good. You can print on the bag if it was a specific operation you were doing. If you're doing a header operation or something, you can print instructions on the bag on how to use it. It's a bag full of water, stick a straw in it, rip the corner off, it's not hard. But you can connect several containerized plants up to one packaging plant to have it running at its full capacity. We're only buying 2 of those packaging plants though, at the moment. So if we take into account training, that obviously takes one out of the system. And if we've got one sitting on a ship somewhere because we're looking at header operations in the Caribbean, that creates its own issues, dare I say it. But proven technology, it works. Like I say, containerized going through its user trials at the moment, or just about to start its user trials. It's been through all the logistics trials, the freezing it and unfreezing it and all that sort of stuff. It's literally now, is it squaddy proof trial? That's where we're at. Okay, a second. I'm going to talk a bit more about this project, Maneuver Power. I mentioned it earlier, and General Nugee, I think you remember this project from your time as well. This was first came into sort of being in around about 2009 as it was called Field Power. And it did what it said in the tin then, all the power that went into the field. And then my predecessors decided that they were going to split that up and they were going to take this and Project Canada, which was another project, and create 3 projects from 2 and create Maneuver Power, Maneuver Shelter, and Static Infrastructure and Power. I'm just in the process of reversing some of that decision and moving the power element of the static infrastructure and power back into this project, rebalancing the finances for it so that we can take it forward as a full power project. And there are some reasons behind that. And principally the reasons are we have had a 2-year delay already due to workforce resource in DNS. So we haven't had a team to deliver it in DNS. And that we did have a team at one point and it got stripped out to us for the Warrior program. Well, you all know where that went. And now we've got no one there to deliver this project. That isn't a bad thing. Because as I said, this was first looked at in 2009. And if you looked at the requirements document, it's, I have generator, I need to replace it with generator. There was nothing taken into account about hybridization, sustainability, or anything at that point. So what we're doing now in the downtime, dare I say it, before we stand up a team, hopefully next year, is we are rewriting the requirements documents. And I've got my team here today. And when you ask difficult questions later, I've got the requirements managers sitting here in the audience and my project managers. So they'll be the ones answering questions. But we're literally going back to basics on this one. The first thing we're doing is we're going back to the power capability and power calculator that was produced by DSTL and Kinetic, and we're looking at that being reworked up, taking into account the size of the current army. So we're looking at the DSD-21 or DSD-16 structures. Everything was around about strike then. We're not doing that anymore. So we're getting the right size bit of equipment for the force that we've got now and trying to aim off for what's coming in the future. We've got battlefield electrification as well. We have one massive issue with this project, and that's that the current in-service power generation equipment goes out of service this year. And there is a contract in place, some people, especially Rolls-Royce, will have heard of the Power Capability Extension contract, which was looking at FEPS generators and keeping those alive for another 5 years. That's slightly taken some iterations over the last 12 months. So it's the in-service support contract now. It's looking at taking our small generators, FEPS generators, and containerized generators, and keeping them alive for the next 5 years, so out to 2027, or 5 years from contract award. Might be 2028 by the time we get there. 60 million was taken out of the MAN-P project in order to enable that. So I lost 60 million before I'd even started, which means I can't buy enough equipment or better equipment, etc. So it has a knock-on effect. But we have to keep FEPS alive and the other generators, because otherwise we've got a cliff edge. Now, we're pushing the cliff edge to the right, to 2027. And what I've shown in this diagram, this drop down in our current power capability is if we literally take a hit of, we using our internal REME, Royal Engineer, Royal Signals, mechanics, etc., keep the stuff alive for as long as we possibly can. So we're talking cannibalization at that point. If we do nothing, by 2029, we will only be producing about 24, the ability to produce about 24% of the power demand that the army need at the moment. Okay, defense needs at the moment. The way me and myself and the team have looked at this, this is what it's replacing, by the way, if you've never seen it before. So you've got lightweight field generator, variable tactical VTEC generator. We've got FEPS in all of its different sizes, plus the power distribution containerized, and some power management system as well. It's replacing all of that now. The studies going on with DSTL that DNS are just about to put out will get our needs and numbers so we can move the money from the SIP project back into this project and do it all in one project. The way we have sold it to D programs, when I briefed him about 6 weeks ago, was we need to do something now if we're going to meet the 2027 timeline, and we need to look at a novel way of procurement, not involving the full DNS team standing up, because the likelihood is, the reality is, that team is not really going to probably become available until probably 2026. Flash to bang in terms of procurement timelines, from DNS standing up a PT to us delivering capability at the moment, is about 5 years. So that's not good. That's 2031. Well, we're now 4 years past when we haven't got any power. So we've looked at how we could do that differently. Literally, this is whiteboards, me and my SO2 sticking our heads, banging them against the whiteboard more often than not, trying to work out what the army actually needs. So we can give DSTL Kinetic the information and they can take it to the next level for us, so that we can actually go down the line of MOTS and COTS solutions and a different means of procurement. And when I talk about that, in the old terms, everyone would think, oh, that's an urgent operational requirement. That's not very well liked terminology in Army headquarters at the moment. So what we're trying to do is look at the in-service delivery team within DNS that look after current in-service equipment, the MODA team, and looking at as bits of equipment are being phased out, phasing new bits of equipment in on a MOTS-COTS procurement. The Army headquarters is looking at putting rapid procurement teams in place, but those teams will not be manned until 2025. So too late for us, but that might catch some of the other stuff that we've got. So we're looking at 3 pretty much systems. We're looking at a small hybrid power generation system, and this would work at, if you like, company level. So you've got small hybrid generator, batteries, and some form of PV solar generation. Some of these bits of kit on this slide here have actually been trialed by the TD6 team in their trials that they were doing. So, for instance, those photos I literally stole off their website. We're looking at maybe additional battery storage that can be pushed further down the line. And then we get down to almost the platoon end of the scale. And what does the platoon need? Because it can't lug these big, heavy bits of kit around. It needs something that's a lot more mobile, can be chucked on the back of a quad bike something small, and they need to be able to charge batteries, radios, everything else down that end. So we're looking at what do they need, and it's probably that small camping style generator, the suitcase generator, about 1 kVA. It's probably a battery storage solution that is separate to that you can plug up and then in the day leave it on with a PV and get some trickle charge going into it. And obviously it'll be the distribution equipment that goes with that and charging equipment. We're looking at a medium-sized system to replace FEPs, but we're not looking at a system that's got 3 different generators. 1 generator that you can modular, basically. So again, microgrid, smart system, probably in the region of a 20 to 30 kVA generator with built-in battery storage of about an equivalent. That then you can add 1, 2, 3, 4, 5 and scale them up. And they're intelligent, they're a microgrid system, they can talk to each other, they can prioritize what loads are being plugged into it as well, and prioritize where the power is going out of it. And then that takes us up to a level where we're at a containerized power generator. So this is the replacement for those big Cat 320, 350 generators. And those that have deployed will quite often be aware that we have these, a field hospital, or we have a 500-man tented camp, and we have 5 or 6 of these generators plugged in. And they're running at about 30% efficiency. Well, that's not efficient for a generator. We want to run at a much higher efficiency. It burns less fuel. Or we run it at the higher end, as General Nugee said, and we burn fuel and we're just not using the electricity. So we want to make that scalable as well. We want to make sure that's got battery storage. And there are various systems that have already been developed and used by other nations as well, including the Americans, that are examples of that we can learn from. This is the area we're a bit unsure about what size it's going to be. I think it will be 100 to 150 kVA sort of size. It might be smaller, it might be larger. And that's what we're going to get out of Kinetic, hopefully. I've put up there reduction in fuel usage by up to 50%. On the previous slide, you saw one of the photos, which was an image from an ARC exercise in November last year, in which a hybrid generator, and I won't say the company, but they are represented here today, put in next to our FEPS generators, a hybrid generator. So we have the actual data, because their generator collects the data, so you're able to take it and analyze it afterwards. On average, over the period of that exercise, in November, with snow on the ground, with very little PV input, it used 50% of the fuel of a FEPS generator. So that's really good, because some of the figures that I've heard, if you equate that litre of fuel to the logistics footprint of getting that litre of fuel there, you can times that by about 14. And now that gives me evidence that I can start using in business cases to try and sell this as the right thing to do now, because we're not just going to buy a big clunky old tier 3 engine generator. Give me the option to have the conversation about what are we doing about single fuel policy. Can we actually buy a tier 5 and run it with an additive, for instance? What's all the logistics issues around that? This system will also let us look at the other bits of green energy, the wind, etc., because this is the static-based stuff now. So we can go a bit bigger. We can actually design this, or we can add to it in a static design. So we can have the basic kit that goes in, and then we can develop and extend on it, and we can add in wind, we can add in as the operation progresses and stays there for longer, etc. Okay, moving on to maneuver shelter. I've got a couple more slides. Maneuver shelter is looking at maneuver tents, headquarters tents, battle group level and up. Now, this project really got hit by the Commander Field Army's Innovation Fund, because everyone who had crappy tents went and bought new tents under the Innovation Fund, said they were doing experimentation, didn't produce a report, didn't give us any evidence from it, and now we've got new tents, so don't care about this anymore. But they're fine. All right, Jack. Attitude very much went on, and that has been stopped stopped now. You cannot buy tents under the experimentation fund anymore because it massively impacted on this. On the order book OBI, that prioritization of all of the projects and programs that are in the land domain at the moment, dropped this down to second from last, and last was static infrastructure and power because of that, because there was no demand anymore for it. But it extensively replaces the ITC tents we have at the moment, the steel framed ones, and it replaces the DRASH tents, the very expensive, very heavy American system that does above secret level. And it was only aimed at maneuver headquarters. And it had nothing in it on sustainability, had nothing about why we're using that type of canvas, why we're specifying that type of canvas. Why are we specified solar shading, but we put nothing in about why aren't we incorporating PV into the solar shading, because then we reduce the material we need and we generate our own power. You know, there was nothing in that. So again, back to square one, rewrite the requirement is where we're at with this. Right? It's also going to do the lighting, and it's going to do flooring and all that sort of stuff. So we're now looking at lighting that is more efficient as well, of course. It includes hospitals, and it includes for everything from the initial pre-hospital treatment facility, the old regimental aid post, through to a roll to enhanced field hospital. That's the static field hospital that we'd be used to in Afghanistan or Iraq or Mali that's put out there. So it'll replace that as well. And we've got to bring all those requirements in, and we've got to make it work for all of the different people that are involved. I then had static infrastructure and power. Now, the reality of this was I was not going to get a D&S team. They hadn't even signed up to providing a team for it. And this provides all of that infrastructure over and above the maneuver stuff. So the stuff that was being talked about for the tented camps, for instance, the accommodation, that was all wrapped up in this project. So putting my common sense head on, I thought, well, that's not right. We'd had a study done by NSPA to look at could they deliver us through NATO partnerships, what other countries were interested, and there was a lot of interest in it, but they got wrapped around the axles of whole force approach and everything else, and really the cost they come back with was just twice what money I had allocated. So then we started looking at how we could deliver this better, because this also includes row 3 hospitals as well. So now we're looking at moving all of the shelter systems into one project. And if we do, again, MOTS, COT solutions, a tent, DCGS asked me once, why can't we just buy, and he put another word in, tents? It took us 3 months to answer that question. You'd think it'd be easy. But to go back to basics, to work out how the whole system works, how can we just go out and buy tents, took us 3 months to answer the question. And the question was, we can't sit, which is ridiculous, isn't it, really? If we've got tents out there that meet the specification, why can't we just procure them? And if we buy the same tents of different sizes, they all interconnect together, and they all work to our DEF stand that we've written, and they're all to a NATO standard, etc., we should just be able to go buy tents and then scale up and scale down as we see fit. And that's where we're pushing towards. But this project, the Maneuver Shelter Project, as it will remain known, because if we change the name again, it'll just confuse people, but it'll incorporate all tentage. That is a lesser priority at the moment than the Maneuver Power Project, because the power demand, and it's going to go and hit the cliff edge. Whereas the shelter systems, they've just put in new contracts for the replacement of ITC canvases, and they've extended the life of the DRASH contract. But we'll get after it, hopefully by 2026. So again, that's all what I've just mentioned, and there is a new DEF stand out for tentage. There was a DEF stand coming out for medical tentage as well, but unfortunately, that, due to organisational change, has been parked. We're also going to look at some containerised systems on the medical side as well. So we're looking at forward surgical units that come already fully fitted in containers, whether that be collapsible containers or solid 20-foot ISO container type. You know, with fixed HEPA filter air fixed power generation and backup systems, fixed gases, and then you connect the tents to them to make the wards and the corridors and the, you know, the lab facilities and everything else that goes with the hospital. One of the reasons for that is we have to make as close to NHS clinical standards as we possibly can, and you can't do that in a tent. I think it's just nigh on impossible to do that in a tent. This speaks to, yeah, I proper nicked this one and I was so glad you didn't use it. So this is the outcome of that case study that went on in Mali. And I think it cements what I've been saying about, you know, and what General Nugee said. 18,000 litres of diesel, and no diesel, it wasn't after a week. 3 megawatts of electricity produced per year, no PV. 11 million litres of drinking water that was in bottles and flown in when the system that was put in by 521 was potable water out of a tap. Yet we brought in bottled water, and we did that in Afghanistan as well. And that's an education piece that really comes down to soldiers like to drink out of a plastic bottle. They don't trust turning on a tap in the middle of the desert, which is absolutely ridiculous. The water that came out of boreholes in Afghanistan before it went through the water bottling plant was of a better standard than comes out of the tap in the UK. And we then had to strip it apart, put it through RO, put minerals back into it in order to put it in a bottle. There was no sense when everyone carried around a water pack or a black water bottle. There you go. And that's it for me. Save the questions for after our next.
So, thank you. So we've got our last speakers on before the Q&A session. So I'm going to invite you up to give Jacobs a place.
How does that work?
Let's
Just hit next.
Okay.
Right. You do first. Okay, good afternoon, everyone. My name is Chris Shattuck. I'm one of the Jacobs team, senior system engineer, working with UTAP Millbrook and Bagtash as part of the TD6 project. So the whole point of this project is to show you where we are in the project right now, and let you see from an infrastructure point of view what you could potentially do with it later on down the line. So hopefully, General Nugee, this should be sort of a nice segue on from what you mentioned before the break. So throughout the presentation, so a bit of a quick introduction. So I said myself, Chris Shattuck, senior system engineer, and Tim McCarthy. Tim McCarthy,
Also senior system engineer.
we are the two Jacobs employees, part of the Tata framework, and we do all the system engineering with and for Millbrook UTAP into DNS. So going off that as part of this presentation, so we'll go into the TD6 objectives and work streams, give you a bit of information on how we converted the platforms. Findings to date, primarily focusing around the MAN-SV, because obviously from an infrastructure point of view, that's probably the one you're most interested in for today. Go into some of the onboard power potentials, and then finally look give you some of the findings from the support and sustain benefits and challenges part of the project as well.
Okay, yes. So this is the TD6 organisation as set up under Army Headquarters direction, and you'll see in there DSTL are there as adjudicators of good and the assessors of the work we're doing. We work very closely as a full team. We do fall out occasionally about things, but we usually end up being happy again. So down the side, the contract holders for in form of MP Aerospace look after the Jackals and the Foxhounds under the PMETS contract, and RBSL were contracted by Rheinmetall MAN who then took the letters off the front of their truck, which was a bit puzzling, to do the work to strip, and the work of the contract holders was to strip the platforms down to the state that Magtech required them in, to then begin the process of making these basic standard trucks into hybrid electric drive vehicles. Okay, so I think these are the objectives we were asked. I mean, at the very top level, Brigadier Cansdale said to us, what benefit do I get from this, doing this to these trucks? Please go away, find out what benefits or disbenefits as well, because there are disbenefits, can be achieved by hybridizing some of our platforms. So the way we approached it is we drew a rich picture of everything that would be required, what would be needed for the 5 parts of the NATO structure of survivability, etc., lethality. Looked at what had been done in past programs, and there are many, many past programs from all around the NATO arena and elsewhere, and then move on to how they could be supported by the UK MOD, because obviously there's a DLOD approach that has to be in there, which involves a lot of stuff to do with safety, and it's not just on the maintainer and operator's part, it's actually anybody who's working or operating near to a hybrid electric vehicle may have a vulnerability, or at least needs to know in case they have. And so what we chose to do was, rather than go for one platform, we chose 3 distinct different types of platform in the form of the patrol vehicle, the sort of more vicious variant with the Jackal, and then the logistics support vehicle as stated. There you go, back. There you go.
Yes, so this slide's basically talk around our technology management, but to give you a bit of background, as part of sort of the system engineering team within the project, not only have we looked at technology management, but we also looked at, as Tim mentioned, the benefits and disbenefits analysis of doing the project. We've also looked at the sustained supportability for the project. We've also pulled together the full config walkthrough. So if this does ever go past an experiment stage, then we've already got that part ready to go. And also we've been looking at the technology management side. So from the technology side, we've now got a full roadmap of mainly of companies within the UK. So what we want to do is keep all this UK based to show, if you were to go out to sort of commercial aspect, you could go to all of these companies, whether it's for batteries, you could go to ABC. If it's a vehicle integrator, you could go to this company, for example, Magtech or whoever else, to put all this together. And it's just to show how far some of these companies have come, even in the last 2 years since we started this project. So at the minute, in all the 3 of these vehicles, we have standard C1 batteries, which you find on a Nissan Leaf. However, what you could probably get now is better power density in a smaller space envelope, which obviously you could add more power if we needed it. But the main thing is, at the minute, these, from like you said, the experiment, we've been very much wet finger in the air. Okay, here's 180 kilowatts of power for the man SV. Is that what you want? We don't know yet, because until they go through the trials, the experimental trials, we can then say, right, what is the requirement? What do you actually need these vehicles to do? If it's more power, I'm pretty sure, especially with where battery technology is, we'll be able to fit more batteries in the same space envelope, and to be honest, probably for less weight, to be honest, overall. In terms of things going forward, hydrogen's taking a massive leap. So if there was to say be a phase 2 to look at new other vehicles, I don't see any reason why hydrogen should be looked at, especially from a commercial vehicle point of view. We've seen 3 companies, or 2, isn't it? 3 companies who are now at TRL 7 or 8, where they're actually testing their hydrogen bands. So there's no reason why we can ruggedize that technology and put it into what you potentially might need later on down the line. So what do we mean by hybrid? So from this point of view, very crude, standard internal combustion engine. What we've done for these platforms is basically taken out all the power, basically taken out all of the drivetrains differentials and replaced with electrical energy. That electrical energy, we've also got the potential to store in the battery or run straight off those batteries. And again, you can see that electrical energy can then obviously go back and forth through the power electronics. We've also got the opportunity from the electrical energy to off-board power, which we'll talk about more in a minute, what those options are. And obviously through that electrical energy, you've then got the potential for silent drive. If you're in a battle situation, if you need to get from A to B, obviously quietly, then you've got the option to do it. And we'll give a bit more on the specs of these later on. Is it?
Okay. So, yeah, we have, as stated, Jackal, Foxhound, and the SV chosen for very distinct reasons to get that variance to see what the advantages of this experiment proves or disproves from different applications and stuff. So, going first to the SV 6-tonner, down here are split batteries, so they're pairs of 60 kilowatt hour batteries split down into 30s. That was basically because we worked out if we did that, we could get more on, because otherwise we'd be sitting just with 2. So we did that. Control units up in the top here. Next slide. Yeah, if we flick to the next slide. So what we've done there is we've basically removed the gearbox, put on the generator or electric machine as it is, put in the controller unit, and all the control units across the 3 vehicles are the same control unit to keep commonality. From there, they control the flow from the generator to the batteries and batteries down to the motors, or direct from the generator. Kept on the SV, we actually have kept the differentials that are already there. So as you can see there, 6 times 30, 230 kilowatt hour generator, which more or less gives you about 500, half a meg. And then you've got your 2 traction motors there. So peak off vehicle export power at the current point, we've put at 40 kilowatts because of the stored energy behind it to back it. This is down to discussion. What do you need off the vehicle? We don't know. Maybe you do or don't know, because we asked the question of many people and we got very many answers. So we sat at the 40 kilowatt thing. So that's where we've gone with the SV. Yeah.
So this is going into sort of findings to date for the MAN SV. So as you can see there, we've now got the increased fuel efficiency, approximately 20% in terms of the battlefield mission scenario. What we have done from within our Jacobs team is we're very keen on pushing through sort of value plus and sustainability plus ideas onto you guys through obviously the Tata framework. And one of our teams pulled together sort of the full cost savings of what potentially could be, not just for the MAN SV, but for the Foxhound Jack as well. So that's sort of going through our iterations with our team, and then that will obviously get passed across to show you the main sort of savings which you could take from using these vehicles. We have enhanced drivability. That's not only from going cross country, but now they're basically like driving a golf cart. So there's no need for, when you go into off-road, you then need to select into your semi-automatic gearbox, and then you've then got to use the gears when driving off-road, which I know it's not the best thing to have to do, and it makes your situation awareness. You decrease that because you're looking down at the gears rather than looking where you're going. For this, it's just foot on, foot off. As soon as you take your foot off that pedal, it will stop and it go again. So it's the drivability is improved massively, especially for any younger guys coming into the army who obviously just pass a test and a Corsa. If they're going to get put into this one, at least it is just an automatic vehicle, and you can just put it down and go. As I said, they had large amounts of torque, so we did a drag race. That's what I put it. But we didn't do a drag race. But basically,
we wanted to see the difference between the 2 vehicles.
And the electric vehicle leaves the old one for dead. They're just
because the problem you've got with the gearbox on this one, it does hunt when you're going up the hills and things. And we basically used the Millbrook Alpine route, which does simulate alpine driving. And then going up, well, the head just disappeared off around the corner and disappeared by the truck by the time the other truck passed us, where we were standing near the bottom of the course. So they're very powerful. It's very smooth, but it's tunable. So if you're looking at soldiers operating this and you feel concerned that that's actually too much for them, you just wind it back with the software, and that allows, and that can all be done remotely by using the MagTech systems. Everything, the batteries are all remotely monitored. The system can be remotely monitored, or it can be set up physically for deployment in the mode that you want. If you're doing a lot of fast runs, you set it up to run fast. If you're doing a lot of off-road, you set the torque so that it's actually good for off-road purpose.
And also the way we've got all that software built in, you can literally be sat at your laptop and say, okay, well, we need to be tuning that to do X, Y, Z. Which is where when we did our show and tell day back last year, we had the MagTech guys back in the offices, ringing up Julian saying, you've only got 20% power left.
Through everybody.
Back it off a bit, and then they're like, how do you know that? Well, it's all basically going through the computer. We know exactly what's going on with those vehicles. In terms of sort of EV driving, so we've got around 80 minutes now driving in and around Millbrook. That's based on the 180 kilowatt hours of batteries. I'm not sure what speed that's doing. That's going around the off-road. That's just tooting around. That's not suddenly. Obviously, if you were to be driving down the M4, you wouldn't be using the EV. You stick it into the diesel mode and just drive on your diesels.
Yeah. So for such as if you were doing long motorway work, shall we say, or MSR type stuff, you can drive it. The generator will be being driven by the engine itself. So you're running in a diesel mode. You come to one of the big cities, or you come to somewhere that you want to get rid of the fumes and so forth. You just switch it across. The vehicle then goes in, does whatever the tasks are, right? I don't know, middle of London, something like that. Come back out and switch it back into electric generated drive mode rather than pure electric.
As it says there, reliability has improved massively. In terms of where we are now with the testing with UTAC, next stage is, as I said, so completing the EMC, signatures, redundancy, and just the general robustness. From the robustness side of things, it's just making sure that we've covered everything, so when it does go to ATDU, that there's not going to be anything which pops off, because obviously for this as an experiment, yes, there's cable ties on bits and pieces, but what we could then put all that ready for when it goes to the actual proper trials.
Yeah, as you can see in the picture, it's got the cooling systems up on the back, so that's because in our head these are just laboratory, they're lab rats, because they're doing an experiment just to get ready. So phase 2, as stated, is to then go down to ATDU, where they will do trials rather than experiment. And that's to do with how do we use these things, how will they perform, and they're all done against a reference vehicle of the like kind from the fleet.
So that's the whole point. We've jumped forward from where in a normal cabin cycle going through a dealer approach, but it was from the cost that basically Millbrook put in. Because what we've done here is this is all COTS equipment on these vehicles which MagTech installed. So it's just been a very quick and dirty retrofit to show what is possible. And in terms of like the reliability, there's been minimal issues across all three.
So I think the one that comes out most is a bit further on, which is the Foxhound, where you'll see the component levels removed of obsolete and unreliable parts. Whereas in here, your reliability figure is definitely improved. It's all common parts across the lot, so your logistic tail is whatever you need there, and they're all made to the commercial standard, which is 5,000 hours before any significant failure.
So this just gives you sort of a understanding of things which you could offer power potential. So obviously we've got potentially half a megawatt of off-board power. I don't think you ever need to do it when you're on the battlefield, but you could potentially charge 17,000 iPhones, 800 kettles, 5 golfs, 5 e-golfs, or power an average house for 18 days. So that sort of shows the level of power which you have got just on one of these vehicles. So I guess looking from your perspective is that could potentially power a field hospital. If you had 2 of those, rather than having, I'll jump on to the next slide, rather than having 9 FEPs, 40 kilowatt hour FEPs there, you could just have the one MAN, which could do what 9 of those do. Obviously, what we would suggest is you probably have 2, so you then rotate them, just in case anything did, any updating or changes need to be made to one, you could then plug the next and plug and play, that one goes away.
I think under this, one of the things we did work out was not to try and do a whole fleet, just do specific task vehicles, because then it leaves you with your standard vehicles to do whatever you wish to do with them, with QMs run, etc., etc. Yeah, so is that a good figure? Depends what you're taking off as a load at the other side as to whether it does that with the FEPs, don't know. But what it does do, it adds to the increased mobility of the actual SV, because everyone who's towed a FEPs knows the nightmares you get once you get into forests and things, and things start going wrong, and your abilities off-road are quite limited. So it means that you are actually able to operate as an off-road platform within reason. You're not as good as certain others, but you're pretty much better than the original variant.
I guess for anything, it gives you another option of a variant for each of these vehicles. So if you're looking at doing midlife upgrades these vehicles, I don't know how much a midlife upgrade would be for say one of these, but we've got the figures for what it would be to hybridize all 3 of these vehicles. So if, for example, you've got a fleet of 5,000 these MANs, if it's potential, okay, we'll hybridize 200, you've then got another variant within your fleet to say, okay, well, we need 10 of these to go here, 10 of these to go there. It just gives you that other option. And another scenario for you also then think about when and how you then use these.
Okay, so as stated, you've got that, and it's each of the vehicles can do this off. It's just the level of power they store. So the Jackal and the Foxhound store 60 kilowatt hours of electric power inside their the current cell configuration. What should remember about the cell configuration, that is a packaging thing. What you can do is you can spiral develop as technologies advance, pull out whatever's in there as that package. And as Chris said, the intent for ATDU is to go from C1 to C2, which gives them a lot more power in the vehicle than we've had for doing the experiment. Hydrogen fuel cells, that could be a potential, not been looked at really yet, but that's a phase 3 or 4, I would suggest, of a TD6 program. So it's DC power, it's 3-phase available, it's 600-volt systems kicking around in there. It literally is ask the question, I need this, and the vehicle can be tailored to suit the need of what it is you need, rather than trying to get a generic power and that's all you get.
I guess you are going to have a new logistics burden from having to train in electrical components. However, even in the commercial world, they're having to go that way anyway. So there's no reason why you can't piggyback off the back what they've already got. It might be then you've then got 2 different squep of officer doing one or the other. But again, that's sort of talks going on forward, and how we would then look at potentially bringing that into service. So next couple of slides, just quickly around the Jackal. So a couple of photos there, some good old-fashioned Sheffield engineering, some bits being made. So as you can see there, the charging port is basically on the back. We've got the batteries currently on the back of the vehicle. Obviously, we know that'd be no good in a battle of a situation. It's because this is an experiment. Let's get them on there. Let's basically show what it can do, and go from there. And the same thing with the control panel. That's a push button system. Tim, who's in the REME, has already said you're going to want some sort of gear stick, because if you're driving around in mittens, good luck pushing one of those buttons where they're so close together. You might end up doing a pirouette when you want to go forward, which obviously would be really good. But obviously that's then going into getting it ready for sort of the robust trials with ATD equivalently. Well, that I think that would be a good thing to do for that going forward. So again, this is just quickly jumping on to sort of the power potential we've got for the Jackal and how we basically laid it out. So Jackal, for this one, we've got motor and gearbox on each wheel. In-body hub drives on these ones because of the way the chassis and the armor is on the bottom of the vehicle. So we didn't have the space envelope available to put them actually in the wheels. We've had to switch out the 6-cylinder for a 4-cylinder engine to fit the 150 kilowatt generator on there. But again, that's not an issue from a basically a fitment point of view. And on this one, again, very much finger in the air, two banks of 30 kilowatt hour batteries to give you the option of when they go to those battlefield mission scenarios and go to test with ATDU. It's how you're going to do it. We've had very much a circular discussion. I wouldn't say a circular discussion on. We've sat down with ATDU and we've said, how do you want to use the vehicles? And the answer back is that, well, how do you want us to test them? But it's not up to us how you test them. It's then the whole point is then we will then once we've got that requirement from you, make sure that we can work within that remit. So when those requirements are properly set, there's a full VBRM suite, which is very much we're able to meet, and we're not going to fall down on in certain areas.
So that's this is the Foxhound hybrid electric drive. Now it's a very, very interesting one to me because somebody had to maintain things like that, because it now has a generator, control unit, battery, fuel tank. We took out 5 post pallets of equipment from this vehicle, much of which is currently going obsolete, so they're scavenging across the fleet to keep the fleet going. And there are other elements that are known reliability problem elements, and they have gone as well. I think a point to note is that whilst they're using a diesel ICE there, they only actually run at 2 settings of speed and RPM. They run at a very low tick over of just about the 1,000 mark, and they run at just over 2,000 when they're doing a heavy load charge. Other than that, they don't rev up and down. They just sit at whatever they need to be doing at the time. With the batteries will go to on electric mode only. They'll go down as far as to the point of like 20% load left in, and then the generator will kick in, or the engine will kick in with the generator. Going up, it will generate to 90% full and then cuts at the 10% in the top, because what all the vehicles do is they do regenerative brake. Regen braking's quite good on the road. It's not so good off-road because you're basically driving uphill all the time when you're off-road, because you're actually pushing rather than just letting a vehicle, if you just let go, will stop quite quickly off-road. So the Jackal is Jackal. Oh, that should say Foxhound. It's Jackal. My apologies. Okay, so the Foxhound here, again, ICE, generator, HV controller, batteries, all as you'd expect to see. But this particular vehicle has hub gearbox, hub motor drives. So that is actually all in. So it's slightly bigger than the standard Foxhound wheels. The standard Foxhound's 20-inch rim. These are 22. This is to give you the increased torque required through the wheels to allow you to perform within the envelope of the original Foxhound. Because that was one of the remits, is we must not change the form of use, the capability, and the envelopes of performance of any of these vehicles. We cannot detract from them. They must all stay at least the same, if not better, in this experiment, and they have. It's as simple as they have done that. And in cases like the SV and its acceleration and so forth, that is an improvement. On the Foxhound, we've taken off the rear steer because we don't need it, because both the Foxhound and the Jackal can do torque vectoring, which means they can do neutral turns. They're capable of just turning in their own length, because it is just the magic of software that's doing that.
Yeah, so last couple of slides. So as we said, we've talked, myself and Tim, we looked into supportability, sustainability for these vehicles. So as it says there, what we have to change or adapt to support hybrid platforms in service, obviously talking as we're going through, but safety is going to be a key thing we need to look at. The maintenance burden, I as well as the training, so operator, maintainer, sort of which way we want to go. Infrastructure needs to be looked at. However, it's to hit sort of the targets coming up, sort of the net zero 15, everything else which is coming up. Obviously, these things are going to have to be looked at anyway. Supply chain, that's a big one. I guess it also depends whether it's going to go down the commercial route or stay with OEMs. But where commercial they're currently leaps and bounds ahead, aren't they? Of where we currently, so we can really jump on probably 5-6 years of where we are at the moment. And then through that, we can basically future-proof through modularity. So as we were saying then, if it's a battery, those boxes are literally just boxes. It's just a plug-and-play system. So your space envelope will stay the same. Yeah. So that's basically where we're at that one. And sustain, it says there.
Yeah, so sustainability. So we've done a full life cycle review of the equipment. The material sourcing, is it ethical sourcing? Because there's a lot of stuff in electric vehicles, especially the older ones, that is potentially not an ethical source material. Rare materials, precious metals, etc., used in there, which are actually not recyclable. A lot of them, they can't reclaim them back. So it's only a consumption. Supply chain, is the supply chain a UK supply chain? Is it a global supply chain? Is it a strategically vulnerable supply chain? Because as we all know, the Chinese own a lot of the supply chain. So as we move forward with the battery technologies to the sodium battery, from the lithium ion battery, etc., hopefully we begin to start to control our own supply chain much greater options. Operation, that's down to the TDU's side of it as to whether this operation is more sustainable. Have we reduced the consumption? Have we got less parts to look after? Is the interval between servicing, etc., different? And the disposal back to the rare earth materials and so forth in there that we actually, and the final statement, is there a real world environmental impact of this vehicle over and above that of another vehicle?
And last one, really quickly, I know we've gone over quite a bit. So if anything, this just sort of shows our benefits and challenges and the potential of where we are with it. I guess it almost just shows how we basically split it into sort of a piece of slides to show where the benefits are with obviously sustainability, survivability there.
I was going to say that's probably not readable, is it?
No, but but I guess the main thing is if you want to go through that, we've got a laptop side, so we can dig into a bit more detail on that later on this afternoon. Okay, so that's us. Thank you very much.
Thank you.
That's all right.
Yeah, don't go anywhere. Don't go anywhere. So what we're going to do now is just going to move into the Q&A session. So yeah, a little warm in here. So can I ask the three speakers we have this morning to come up and take a seat? Sorry. And what we're going to do now is just do a bit of a Q&A. So we are running a little bit behind, so we'll do this for about 20 minutes unless these fast and furious questions come in. We might go a little longer. But this is your opportunity to raise whatever questions you want or any concerns to the speakers. Please, if you want to direct the question, say who you'd like to direct it to. If it's an open question, put it out there and I'll channel it to one of the speakers. So does anyone want to take the first question? Go on.
I'll start. Phil Williams from Cdre. I guess question for General Nugee. Preaching to the choir here, everyone's pushing back and saying it's not a good idea. So what are the main blockers within model to sort of get through, get past? And do you think the InstRE review that's taking place right now is going to help or hinder?
So the main good question. I think there is a degree of distraction. Ukraine is dominating a huge amount. And I think, therefore, trying to persuade people who perhaps instinctively are coming from the view that this is an add-on, which is just cost, that can't find advantage out of it, is going to be dominant amongst those people who are trying to concentrate on Ukraine. So I think that's one of the problems. I think one of the problems is momentum. We have to build momentum. And that means that it won't necessarily be the most efficient system, and that we won't necessarily be massively cohered and so on and coordinated. And that sometimes is a reason for stopping. If we're not completely in sync between the Army, the Navy, and the Air Force in every respect, then we'll just not do it. I think that's a problem. I have a view that building momentum is more important than being efficient at this stage of our development of this. And we should just get on and do it, and eventually we will come to a conclusion that actually there is ways that we can cohere. But if you start on coherency, then actually you'll get nowhere. Because trying to cohere the Army, Navy, the Air Force, trying to cohere the Army is close on impossible anyway. So trying to bring all three together with strategic command, I think, is just a non-starter. So get going and build momentum. There is inevitably something described to me as political headwinds for the next 2 years are going to be difficult. I don't think that the very top of politics is necessarily working in our favour in every respect at the moment. But what gives me some reassurance is reading the front page of the Telegraph today saying that the defence budget is going to be 100 billion by a few years' time, which is a over-doubling of the defence budget. I hope the Telegraph have got that right. I find that quite difficult to believe. But some increase in budget should allow this to be seen as what it is, which is a game changer in terms of finance, but you have to put the capital up front. And so I think that there are a number of things which are going to be difficult. And then you have finally a culture of we don't need to do this. I think that's disappearing. I genuinely think that's disappearing, but that's what I was hit with 2 years ago. So it's not that new. Oh, sorry, it's not that long ago. But that was the culture.
I just hope that we've got that momentum in place for when the InstRE review finishes this year and the extra money. And I'm not sure Ben Wallace is being completely optimistic about his 100 billion, but the fact is that it looks like there will be more money for the defence in the next.
Yeah, no, I think there will be more.
So even though 3% of GDP, and I do worry that GDP might suddenly become quite a small number, so 3% is a small number. However, the traction seems to be, although Ukraine is a distraction, it's highlighting to the public that you need to have a strong military. I just think if we get that momentum right, what we're trying to do here, then you will get the next generation on board as well to say, great, we can go and fight wars and be green and be just as capable and more capable.
I completely agree, and I'll just add one comment, and I don't know if Andrew will try and do more, but for me, Epoch 1, the first 5 years, was all about building the processes and procedures in place and the policies in place so that defence could never go backwards. We tried this in 2010. We had all sorts of experiments in 2010 of trying to be more sustainable, and the moment that the person who was driving that left defence, the whole thing collapsed. I am absolutely determined that doesn't happen this time. And by doing that, you have to build different processes, different procedures. It's very dull. It doesn't hit the headlines. It's quite difficult work. It's commercial. It's how DNS operate and so on. But actually, getting that right in the first 5 years sets the foundation for the next 25.
Thank you for that.
Yeah, I'll agree obviously with everything the General says. Mostly do. But I would add 2 points, I think. Industry can help us and put the pressure on defence. There's a conversation 2 ways here. And if industry is saying, we need your policies to trickle down further, the policy, procurement, etc., we need you to be demanding more from us from a sustainability perspective. That will drive the commercial policies that trickle down from defence. And eventually, we all get into that virtuous circle. Your investors are happy in industry, the financial flows are happy because we're all sort of ethically investing and the world keeps turning. So I think there's a big 2-way conversation here. So defence needs to do its bit, but industry can put pressure on defence to accelerate that process. And the other point I was going to make is back to what I think both General Nugee and I did refer to is stealth sustainability. It's don't talk about sustainability, talk about what we can invest in that is brilliant for operational advantage. Do you know what? These just happen to be also amazing for our sustainability credentials and defence. And so with the political headwinds, with the additional money, they're the big hitters, and that's what we need industry and defence to work together on to highlight, to say, well, that is the, you know, the energy strategy may help us with that, but they are the technologies where we're going to be world leading. They're going to give us great advantage, and they're also going to give us that self-sustaining sustainability advantage.
Thank you. Any other questions? Let's go.
So Liz Sullivan, Royal Air Force, but got this convert into Rolls-Royce. And it kind of links to that question, and it's really about culture and behaviours. And we've touched a little bit on it there, but also the bottled water example. So, you know, how are we looking at that internally? What's our strategy within defence to make lasting behavioural change which will drive that culture? So, in the example there that you used, General, that when somebody leaves, it doesn't all come tumbling down.
So climate literacy, education, societal factors, I think they're all at play there. I think, and I think we need to hold the senior leadership of defence to account. And you know, increasingly, I see myself in that position a little bit. So it's sort of in that between, you know, the people out there are dying for this stuff. We want, you know, they don't want to be stood there with a plastic bottle of water that they throw away after they have 3 sips, which is what we've been doing. It's the culture of behaviours in defence for years. I mean, just piles and piles of, you know, overheating plastic water that's sat out in the desert. I mean, what will we do? So I think one of my photos actually brings that out. It's like, you know, we've all seen it on operations. So I think we should be putting pressure on the senior leadership to make that change. And I think the technology and innovation that's out there now is allowing us to offer solutions at the same time we present those problems. And so we just have to marry the two sides up. And I'm a firm believer that education at the very top of defence should be the first priority. Now, Julia Powell's coming to speak tomorrow from DCNS Directorate, and her lead is on that climate upskilling, literacy and skilling. And I believe that we really do need to start at the top, because there's still, and I don't know, I'll be repassing officers, General Nugee probably dealt with many of these. You know, there's a real ignorance still, in my view, about the small changes we can make that will be inherently more efficient and beneficial. And water is a prime example. Mali, why are we not just drinking the water from the borehole rather than flying it in? It's crazy.
The other thing I would add there is incentivisation. You know, if you were to find a way of incentivising some better practices about sustainability generally, then I think that that would have material effect. I even suggested to Richard Wardlaw that when you leave the armed forces, so I left the armed forces, the entire of my car had 30 years of detritus left in it that I offloaded to the quartermaster. And he said, "Thank you very much." I then went to have coffee with the commanding officer whilst they sort of sifted through this mess of steel helmets and things like that I started in the early 1980s. When I went to the quartermaster, I said, "How much of that have you been able to recycle or reuse?" And he said, 3 items. And so the logic of that was actually there was no point in me taking it, frankly, because it was just all bin. Which is the policy we have at the moment. So I said to Richard, why don't you just say for every piece of military kit you bring back when you finish, you're given £2 or £5 or £1, doesn't matter. But given a small incentive to bring something back, so there's something materially advantageous to you for bringing back a piece of kit, which actually, if you don't have the recycling capability of materials or whatever it is, of respirators, and I still have a 1980s respirator and a 1980s respirator haversack, it would have been lethal if I'd used it. But you know, if we have some mechanism of recycling it, then actually having a small incentive to bring things back, you get 10 pence for every water bottle that you put into a recycling bin rather than just chucking it on the desert floor. Something like that will actually change behaviours as well. So it's not just education. That assumes that everybody listens to their education. I don't think I listened to my maths teacher. And so actually, it's more than education, it's incentivization.
Just while we're on that question, so is there like someone in command of a design organisation, how would you implement that within your organisation?
Well, okay, there's an interesting case for bottled water. SQE Middle East last year replaced all bottled water with water filters across the Egyptian journey. So they made the default option the right option. So they removed that from there. And from the grassroots, it was seen as a good thing. Our young people absolutely want to get involved, and they want to get involved. There's just some resistance because it's almost embedded in our culture in terms of how we do that. We just go for the bottom water. We can't go to the old manky jerry can that we used to have in the back of the game of the warrior and pull that out with a mouse that's been living in that for a couple of months anybody touring around batters. So we've got to make it attractive. We've got to make it the default option, the right option. And I think if we try and automate behaviour as much as possible, that's how we'll get through cultural change. So we make it difficult to do the wrong thing, we make it absolutely positive to do the right thing. That is the way.
Thank you for that. So I'll take one from the front and then we'll take one from the back.
Richard Brown, Head Infrastructure Plans for the Army. I'll respond to your challenge, Jeff, and say the Army does have an energy incentivization fund getting after reducing our utility bills in barracks, in the home space, not the deployed space. The question, though, is we will almost certainly still be emitting carbon well beyond 2050. Some of our equipment will almost certainly not be qualifying for high there. Is there too much focus on net zero in operation rather than sequestrating those emissions that we'll still be pumping out? And to be honest, the carbon dioxide we should still try and put out of the atmosphere to get the climate back.
I've been quite impressed with just recently, very recently, with the beginnings of technologies that will take carbon out of the atmosphere. Realistically, at the moment, there's a carbon capture, I think, in Iceland, which takes 8,000 kilograms of carbon out of the atmosphere a year. That's not going to go very far when we're putting 30 billion into the atmosphere. So it is carbon capture from the atmosphere is very difficult, but you're beginning to see technologies that are slightly more realistic, which is good. Actually, carbon capture from industrial processes is a better way of doing it than do it because it's that source effectively. We're beginning to see a bit of that. But you're right that actually sequestration through our estate is going to be the only way we get to net zero. There is not a hope in hell of cutting our emissions to zero, not in the next 50 years, I argue. And therefore, we have to find a way of net zero. That has to be sequestration. And what that means is slightly modifying our training state. It might make training more difficult, but that's not necessarily a bad thing. And so you put a few bolts in where we've been draining the training area for the last 30 years. Interestingly, Sunnybridge has only been trained for 30 to 40 years. That means prior to that, we weren't draining it, which meant that it was more difficult for infantry to walk across. I get that, but actually that may not be a bad thing in some cases. But actually there's a logic here which turns around and says if we optimize so that we can train and we can keep our training state sequestering carbon in the way that it needs to, then we can get to net zero. But without that, we're never going to get that. It's very good.
Thank you. Would anyone else like to put anything on that?
There's just one bit on the TD6 front, because you've got mass stored batteries on those vehicles. What we didn't say was they can actually charge off the normal grid inside the base. So if you have your fleet stored inside the base, not only can they charge, if you had solar, etc., on top of the base, they can then discharge back overnight. So you can start cycling there. So you're actually using what is in fact a mobile asset as a static battery.
Good point. First,
Because I can from that multiple just wanted to Rebecca to be really interested in about the hydro power, the installation, renewable energy generation. It seems to me like there's really about to say at a technology level where this can be recognised quite quickly and reduce the kind of inertia and saying about the inertia the buildings that momentum. And it's as opposed to mentioned about reluctance to kind of use the or use the get some urgent operational requirements in pushing some stuff. But it seems to me like that's really what is needed in terms of using recognising aspects up. Why aren't we recognising sustainability and becoming more self-contained operations in that
think ignorance. Actually, genuinely, I think people don't understand what's out there. And my goodness, there is so much going on that I think it's really difficult to focus on what is actually going to be advantageous and what isn't. There's also quite a lot of snake oil out there, and there's a massive amount of greenwashing going on by companies. And therefore it's quite difficult to navigate between what is genuinely game-changing and genuinely going to make a difference for the military. And the military can't afford necessarily to get things too wrong and bet the whole of the defence budget on a technology that isn't going to work. And we've done that before, but it's not a very good thing to do. And so I think there is a slight hesitancy because it's public money and we don't yet have enough of it. It's slight reluctance because we don't know the landscape well enough. And I think a slight sort of hesitancy because even when we're told something, because it's all such new technology, it's quite difficult to prove it to the level that we want. That's why the TV6 demonstration program, I think, is so good, because actually we're taking something which is, frankly, should be relatively basic technology now, a hybrid drive on a vehicle. You know, we've been doing that for a while, but actually putting it through its paces properly in a military context, and then coming out with, wow, this is really quite good in lots and lots of different ways, then we will convince everybody to then buy it. So I think there's a whole reason why that's happening, but I don't think any of it can't be.
I think one question, if that's not coming forward to do it, coming forward not to do it,
but as was said earlier, you're talking to the converter.
Yeah.
So we'll take 2 more questions before lunch.
You mentioned a little bit earlier about digital technology, and I just wonder about the sort of low-hanging fruit, if you like, that comes from better understanding how we're utilising the equipment, increasing the availability, reducing the amount of maintenance, increasing the fuel consumption from what you're using, maybe even reducing the asset base because you're increasing the availability of the assets you've got. What's your sort of thinking around that moving forward on it right across the military?
Yeah, so good question. And availability, back to the defence support strategy, is a key part of that, increasing availability. And there's a study at the moment, Rear Admiral Andy Kite is doing a piece of work since he left being my boss, but for General Wardlaw still, on increasing defence outputs. It's a specific study to enhance availability that he's doing at the behest of CDS, and this is all about sweating the assets in defence. Why have we got ships tied up that are saving fuel, was example earlier, and they make those ships more efficient, do things better. So that is absolutely an early target. So before perhaps we can get over that bridge and have the investment to get to the scaled technology. So that's really the technology out there. It's scaling it and bringing it into the core program and getting it funded. But in the interim, what are we doing with what we've got? Why are we not sweating those assets better? So getting after greater availability, hums, predictive technology for maintenance on our capabilities. We should be using that. We have got the ability now to know when maintenance, but we still work quite often on certain platinum pipes to a regular drumbeat of maintenance because that's what we've always done. We maintain them every 6 months and we give them a major service every year, whatever it may be. Why are we doing that? This data is telling us that you only need to do that every 2 years because it's a perfectly sound piece of equipment. That piece of equipment could have not been off the line for the 2 months it took to do the maintenance, making up the figures, obviously. But the whole point here is, yes, predictive maintenance is a huge part of that in improving platform availability. One of the 6 initiatives in the Sustainable Support Strategy is starting to exploit the digital technology that is out there already to be better at delivering what we've got and designing in then those sort of data capture capabilities for the future. So that's good.
Thank you. Go on.
So as stated there, our vehicles are full hums. The origin Foxhound is also a full hums vehicle, and it's switched on the MANs as well. It needs to be a whole managed fleet,
You need to rotate your vehicles rather than just take the front row, put the front row back, take the front row, put the front row back. So you need to put your fleet in a pattern that allows for a rotation of all vehicles through in use for training, operations, whatever. A number of studies have been done, reliability, availability, maintainability, decision piece there, and obviously a HUMS RCM study as well has been done over the last 10 years. And the results are given. So we'll just give the results and just sit there.
Yeah.
It's very sad.
So yeah. So I think in the spirit that the next generation is the younger generation, I think we should open up the room so someone below the age of 40 to ask a question, which is mainly sitting this one. So has anyone got a question from the younger generations to ask a question? Go on. Yeah. Please feel free to ask questions.
So the discussion's sort of been around policy. Where do you see technology and policy balance being? Is it that the technology is there? Is it or the technology advance?
Okay, the technology's there, just need to use it in terms of where we go. But we need to understand what our requirement is first. So it's looking at that and going, right, from a tactical perspective, across the estate, we're using energy here at this time we're doing it like that. We just need to do that better. And that's what we're doing. It's just, it's understanding the requirement and the policy.
But I would add to that as the world gears up to being terrified in 2045 at 2.5 degrees of temperature being predicted, and we've got floods and everything else all over the place, which I absolutely think we might end up at if we don't do anything. Technology will take another leap forward, and we will try and innovate our way out of what has become an absolute nightmare world to live in. And I think, therefore, that technology is there now. We must use it now. But keep our eyes open to the fact that technology in 20 years' time is not going to be the technology of today. The digital world's moving really fast, the virtual world's moving really fast. Actually, some of the mechanical world is moving faster than we anticipated, despite the fact that we think we're really good at sort of basic mechanics. So I think trying to keep our eyes open and innovation is going to absolutely leap forward, I think, because people will genuinely be really rather frightened by the sort of world we're living in if we do nothing.
Okay, so you got to come back?
So you're talking about the requirements. Are you looking at requirements now? Because obviously, if you're looking at completing digital, they go up quite a lot more.
Yeah, and that's why we're kind of going with in terms of what's going on in the future. We already know automation is coming. We already know that generating those fuels is going to be more intensive. Our power keeps on going up and up. You look from the past, it just keeps on going. So we need to look forward to how we're going to generate and having the skills necessary to do that.
What I would add though is we need to do it now. And the problem with our procurement system at the moment is it can wrap you up and you can think what's going to come next. Should we just wait? What's going to come next? Should we just wait? And if we're working on a system that tries to keep a bit of equipment in service for 30 years, well, actually, let's get away from that now. And we can't go down necessarily spiral procurement, but we need to look a lot shorter term. We need to get on the bandwagon now. We need to take that first step. And in 10 years' time, we might be replacing that equipment, or we might be giving it a midlife upgrade, and then moving on. And the next best thing is going to come in. And it's not going to be for my generation, it's going to be for your generation who is sitting somewhere where I am to make that decision. It's that far away at the moment. But if we don't make that step now, we will be here in 10 years' time talking about safety.
And I think we need to take into account that we've moved from a consumer disposable based economy, and we need to move much more into a circular economy where we do midlife upgrades correctly and appropriately. It means stripping back to the chassis, but don't, because the large part, as identified, is the industrial process of production, especially with alloys. If you're using alloys, that is very consumptive and has a massive carbon footprint. Simple thing, I put in a cost-saving and sustainability piece for the boxing program. Don't get rid of the heavy cam off the SP fleet that you get rid of. And I can't remember, it's hundreds of millions of tons of saving in carbon capture because you weren't remaking cam bolts. Simple as that.
So as we're running a little bit late, I think we should call it there on these. I would like to say thank you for the speakers for coming up and sitting there. Can we give a round of applause to the speakers, please? And as we've eaten into the lunch a little bit, can I ask that we come back at 2:30? So we'll have an extra 10 minutes on for a bit of food and networking. Okay.